Hello my dear students, how are you all? Welcome to Diksha Karnataka YouTube channel. I hope all of you are doing good. Bacha, today I am here with the most awaited session for mathematics for PU2 boards, the final battle, the final revision, the Maham revision for maths from my side for PU2 board students. Okay, so we'll do one short complete math revision. All chapters we'll discuss the formulas, we'll discuss the questions, we'll do everything. Okay, so I hope you are prepared for that. In the live session that we had, you were all asking for it, and as I said, we'll be coming up with very soon, and this is the session over here. Okay, so I know the time is very crucial for us. We'll not waste any of our time. Quickly start the session. What is coming for us? Bacha, over here, please check. First thing I want to tell you, all of you, is please go ahead and check the free trial right now. I know I'm getting your responses. It was very good, but for Abhyas case test series is a very unique test series, bacha, that we have come up with. Okay, what you can do is right now avail the 4 free tests provided to you. Physics, chemistry, maths and bio is given. Each paper will have 60 questions as per standards. Okay, you get question paper, you get video solutions, and also you get video solutions for each of the chapters. Okay, now what else is there, sir? We have 31 paid tests in this. Okay, in the Abhyas case set for 2025. What 31 paid tests, which will start from 17th of March. Okay, so because once your boards are over, then only you can spend time in any of the other things. So that's why 17th of March we have kept the paid part will come. You'll have full syllabus and chapter wise tests in that. Okay, again you'll have detailed video solutions and analysis of that. Chapter wise one shot revision video will also be given to you, and chapter wise insight for last 5 years for case set papers will also be given to you. Okay, now if you check all of this, okay, you can get this entire package at a price of only $14.99. This is the launch price. Not much is there. I know. If you're not sure about this, do one thing now. Don't buy it right now. Go for the free trial. If you feel it is actually good, and I know you will feel that is good, please go ahead and purchase it right away. Don't wait for the exams to come, boards to be over. Right now you can purchase this. Okay, and let me know if you're having any difficulty purchasing this test series. Let us know in the comment section. I'll tell you what, you might find other test series available right now in the market, but not will be any good. Then none of them will be as good as this one. One best thing about this test is that, bacha, you get to write the test live. What's the meaning of that? It means you will have questions on your screen, you pick an option, then you move on to the next question like that. Okay, like proper examination, not question paper, not answers. Proper examination will be given to you. You can sit for that amount of time, 1 hour, and write your answer. Okay, so please go ahead and purchase this test series right away. Let's move on to the question now. So first chapter we're going to discuss is continuity and differentiability. Okay, so what we have over here, please check. A function fx is continuous at x equals to a. When can we say that, bacha? When the limit exists. I'll repeat myself. When the limit of the function exists at that particular point and should be equal to the function's value. We cannot say that only the left hand limit exists. We cannot say the right hand limit exists. The definition is when the limit exists, left hand limit should exist, right hand limit should exist, and they should be equal to each other. When that is happening, then only we can say limit exists. We have learned that in PU1. So when the limit of the function exists and that is equal to the function value at the same point, then you can call the function to be continuous. So limit, you can see here, this part is what, bacha? This part is LHL, sir. This part is LHL. What about this, sir? RHL. So the LHL and RHL should be equal and should be equal to the function value. When we say that, when can we say that? That is called as a continuous function for the given point. Continuous function for the given point. What we have, I have mentioned over here, left hand limit, right hand limit. Okay, let's see. Chaliye. Now find all the point of discontinuity. All the point of discontinuity of f, where f is defined by fx equals to this. Okay, how can I define it, sir? Let's say the point is x equal to 0. No, if I take, bacha, after 0. If I take a value after 0, what will happen? Let's say I am taking the limit of the function, sir, on the right side of 0. So RHL I am taking, bacha. What will happen to this? Tell me. It will become, sir, actually plus x upon x only. Because on the right of x, mod x will open with, sir, positive sign. Think about it. Take a number more than 0. 0.2 I can take. 0.2, if you apply mod on that, what is the answer, bacha? 0.2 only, okay? There is no sign change over there. So it will open with a plus sign. Can be cancelled. Okay. What is the answer, sir? Simply 1. Answer is simply 1. If you apply limit, again you will get what? 1 only. You will get 1 only. Whereas, if you take, sir, the limit of the function 0 from the left hand side. We are talking about LHL. What will happen? Please check. Mod will open with a minus sign. So you'll have minus x over here by x. How come, sir? Think about it. I take x equals to something, right before 0. I get, let's say, minus 0.0005 if I take. Okay. Apply mod to this. But a mod will open with what? Minus of minus 0.0005. Okay. What I'm getting, sir, please check. It will become plus only, right? So anyway, we should know that mod makes everything positive. How it does that? By applying a minus sign if it is negative. Okay, if the value is negative, it applies a negative sign to make it positive. It means if x itself is negative, then to make it positive, the mod will open with a negative sign. That's why it is minus x. Cancel it. What is the result, bacha? -1. So as you can see, the LHL value is not equal to the RHL. Okay, in that case, what do you say? We say, sir, limit does not exist. Limit does not exist. Then of course, bacha, how can we say the function will be continuous? Not continuous, sir. So we have only one point of discontinuity. If you want to plot the graph, please check. The graph will be like this. At 0 is going to be, bacha, if I draw the graph over here, at 0 it will be 0 only. After 0 it will become simply open 1. Please check, open -1. So we have only two values, -1, 1 and 0. Means at 0 there is a discontinuity in the function. It becomes equal to 1 right after 0, right before it will be -1. So discontinuous at only one point, which is x equals to 0. X equals to 0. If I go after this point, no 0, I take 1, 2, 3, 4. What will happen, bacha? The graph is continuous. The graph is continuous. I'm not saying 1, 1 on 2. Understand this? It's continuous. Okay, is there a break in the graph after 0 point? No. Before 0? No. So there's only one point of discontinuity, which is nothing but x equal to 0 is the only point of discontinuity. Please check. I hope this makes sense to you. I hope this makes sense to you. Shall I move on, please? Okay. So what we have now? Examine the continuity of the f, where f is defined like this. Okay, how do you find it, sir? Again, same concept, bacha. Find LHL, RHL and find the limit value from there. So if I apply, sir, for LHL, please check what I'm gonna get. Applying the limit, okay, sin x minus cos x. When, bacha? When x is tending to 0 from the left hand side. From the left hand side, what will happen to the function? Please check. So I'll get this, have a look. I'll get this, excuse me, I can change this, no? Limit s tends to 0, okay? And write this as 0 minus h, no? Write this as sine of 0 minus h minus cos of 0 minus h. Don't ask how you know this, right? Property a minus h and a minus h. In place of x, what we do, sir? Applying with this for the LHL part, a minus h, no? A minus h we write in place of x, bacha. We know this, okay? Chaliye. What we're gonna get now? Over here, sine of minus h is there, no? It will become minus sine h. I'll have over here, cos of minus h will be simply cos h only, right? No change over there. Apply the limit now. Limit is what, sir? S tends to 0. It will give me minus 0 minus cos of 0. How much I get? Minus 0 minus 1. How much is that? Simply minus 1. So this is the value of my left hand limit. Left hand limit. Okay, this is the value of my left hand limit. Second, what, bacha? Let's find now. Similarly, RHL. What we'll do in this case? Replace x by 0 plus h. A plus h, na? In this case, a is 0. That's why 0 plus h. Okay. So right here, please check. It will become limit of the function h tends to 0. I'll write here sine of 0 plus h minus I had, right, cos of 0 plus h, same thing. What I'm getting now, please check. Sin h minus cos h, when limit h tends to 0 will give me, sir, 0 minus 1. Again I'm getting this value as, please check, minus 1. This is nothing but your RHL. So what I'm getting, bacha? LHL equals to RHL equals to function's value at same point. How much is that? Minus 1. This is the definition of, bacha, continuity, no? Hence the function f is continuous at the point x equals to 0. Makes sense to you? Does it make sense to you? I hope it does. Okay, chaliye, have a look. Let's move on now. So we have next is differentiability. What we do in this? We take help from first principle of derivative. That's what it is. F of a plus h minus f of a upon h. We can apply this for both condition, bacha. Left hand derivative and right hand derivative. Replace with a minus h, and what about this, sir? Minus h will become for left hand derivative. Okay. and for plus you'll take, it'll become RHD. It'll become RHD. Agreed? Okay. So we'll see how this is applied. I hope you know this, right? Most of the question doesn't require to apply this. Only for derivations, no. I'll tell you what. All the formulas that you know in differentiation is derived using this principle only. Yes, you derive all the formulas using this principle only, okay? But good for us, we don't need that. They don't ask us derivation for formulas of differentiation, okay? So we can use the conditions of function definition only to get the result in derivatives, okay? So let's check some questions I have taken on that. So prove that the function f given by fx equals to mod of x minus 1. So see, I'll just define the function and then differentiate it, then get to the result. What is that? Please check. Mod of x minus 1 at the point x equals to 1. Okay, define for bacha function. F of x is like this when x is equal to 1. When x is equal to 1. What is that, bacha? Please check. Okay, so when I do that, okay, let me just change something. Not equal to, I can take here greater than or equal to, no? That will be better actually. Please check. Greater than or equal to, and I'll take x is less than 1. Okay, this makes sense to all of you. I have divided this entire, what is this, bacha? X belongs to all real. The domain is all real. I've divided into two parts, from negative infinity to 1 and then 1 to positive infinity. Makes sense? Okay, so before 1, bacha, what we are getting? Please check before 1. Put a value before 1, no? Put 0. Is 0 before 1? Yes. 0 minus 1 will be minus 1 only. What will happen to the mod? Sir, 0 minus 1 is there, it will become minus of 1. So mod has to open with what, bacha? Minus of minus 1 will become, sir, what? Plus 1. Okay, it means basically this function will be operated with a minus sign before 1. So I get what? Minus x minus 1. Minus x minus 1. Agreed, na? And same way, after 1 what will happen? It will remain positive only, na, sir? Not plus 1, sir, x minus 1 only, but it will be positive sign outside the bracket. Okay, great, this part is clear. Okay, now I can rewrite this. It will become, sir, minus x plus 1 actually. I'll erase this part. This is the same thing. Okay, this is our function actually. I'll erase this part. After opening with a minus sign, it will become minus x plus 1 only. No, this is your function before 1 and after 1. Now what do you do? Find the LHD and RHD directly from here. Please check. Not relevant now, these steps. Okay, acha bacha, I'm not taking this question to that this question will come in the examination. That's not the point of this. I have done those kind of questions already. 1 marker, 2 marker, 3 marker, 5 marker. Okay, I've done model papers. A lot of things are done. Yes, we are doing questions over here as well. But these questions that I've taken, no, some questions will not be for the exam point of view. I've taken to explain the concepts also. This is a marathon, right? We're gonna learn all the chapters in the best way possible. At this given amount of time that we don't have much time right now, so whatever time we have, we'll try to learn everything in short, but it should be precise. Okay, that's why the questions are like this. Okay, chaliye. So what will happen, sir? We'll take now, please check, we'll take the bacha left hand derivative. We know one thing for sure, right? For differentiability, LHD should be equal to RHD. If I say LHD equal to RHD means any function f will be differentiable. Correct, this is the condition of differentiability, right? Okay, let's check for this function. What is LHD, sir? In this case, please check. I'm going to use this part for LHD, differentiate this part. What I'm going to get? It will become minus 1. What about this bacha? I get RHD as, differentiate this, I get, for x I get 1, for minus 1 I get 0. Over here, for minus x I get minus 1, for 1 I get 0. So I'm getting RHD as 1, LHD as minus 1. Of course, from here I can see LHD is not equal to RHD. Therefore, what happens, sir? The given function is non-differentiable. Therefore, the function fx is non-differentiable function at x equals to 1. At x equals to 1. If you want, you can see this clearly. This is a modulus function. What happens there? At critical point, it will be having a corner point. Okay, it will be having a corner. Okay, so x equals to 1, no? It will having a corner, that's why non-differentiable. You cannot have sharp corners, right? So please check. Moving on now, next thing. Now basic differentiation formulas, I know you all know it, I've given you formula sheet already, but still we'll go through that all of it, okay, one by one. Very quickly we'll do, but we'll go through it. For constant we get 0, for x with the same variable I get 1. For this bacha, polynomial very useful to us, n times of x power n minus 1. For sin x is cos x, for cos x is minus sin x. We use this multiple occasions, no? Won't you agree? We have used this so many times bacha. Cos x, sin x, है ना? Tan is x square. This is also very useful. Cos x square x for cot. Tan is x square. For sec x we have sec x tan x. Cos x, cot x. These formulas are very useful actually. You can see in the questions, very useful. Not only in solving the questions, also in taking the substitution, right? When you integrate, in the case of integrals, of course, in indefinite integrals, what happens? You make use of these substitutions, right? These formulas, right? Okay, chaliye. Again, in logarithmic function, bacha, we have for exponential function, please check. E power x remains e power x. Ax power x, bacha, becomes a power x times of ln. Don't forget ln, okay? ln is there. Then we have ln x equals to 1 by x. Log x becomes 1 by x ln a. 1 by x ln a. There's a difference, but please learn it, formulas. I know you all know this already, but still wanted to revise these things for you. For trigonometric functions, ITF, what we have, sir? Sin inverse is 1 upon 1 minus x square in the root. Okay. For cos, what will happen? Same thing with the minus sign. Same thing with the minus sign. Okay. What about this tan inverse, bacha? It will be positive without any root, 1 plus x square. What about cot inverse? Just a minus sign will come in the numerator. Okay, that's how you remember these formulas. For second inverse, you'll have mod of x square minus 1, just opposite of this. It is 1 minus x square, no? It will become x square minus 1 with mod of x. Over here, you'll have same thing with the minus sign in the case of cosec inverse of x. These two are very rarely asked actually. Mostly these are your important ones. The first, I would not even say the 4, I would say first 3 is more than enough. Sin inverse, cot inverse, tan inverse, that's more than enough for you. Have a look. Moving on now these rules, they are like goldens, right? You get the use of these rules in every question coming from calculus, almost every question. Okay, in differentiation to pakka you get. Okay, what is there, sir? Sum rule. Okay, means if you have to take differentiation for two different terms over the sum, you can take individually also. So take first derivative of f, then derivative of g. So f plus g dash will become f dash plus g dash. Next, if you take product rule, what will happen, bacha? You take first function's derivative, keep second function as it is. There's no preference order over here. There's no preference order over here. You can take any way possible. Okay, basically you can take one of the functions derivative, keep the second one as it is, then you put a plus sign. The whatever you did not take derivative as in the previous case, you take derivative of that. So take here f dash g, f g dash. Here g was kept as it is, here f is kept as it is. I hope this makes sense to you. Yes, sir. Quotient rule. What I am getting over here? F by g dash. F by g dash. What I get now? First function. Now this over here, no, in quotient rule, preference is important. Not preference, like, not like in by parts. Preference means numerator denominator. Okay, there's a rule for that. First you have to differentiate bacha numerator only. Means what is the numerator over here? Please check. The numerator over here is f and denominator over here is g. Okay, so you have to take differentiation of f first, please check, and keep g as it is. So first f, keep g as it is, minus sign will come in this case. Now in this time, keep f as it is, take g dash, divide by whatever is the denominator, square of that. Please check. Okay, chain rule, sir. What happens is, we have seen the questions, log, tan, polynomial, all will be given at one place. You have to differentiate until unless you get one, or get for the, what you call, no more variables or no more functions are left. Over here, first you do for f, then you do for g, then you do for x also. Please check f, g, and you have not done for x because it's going to be 1 in this case. That's why not done, but it have to be done in the case of, let's say it was y, no? Let's say it was y in this case, we have to do dy by dx over here. Getting my point? Okay. Second derivative, bacha, this is again, you can see a lot of questions are being asked in 3 marker on this. Second derivative is nothing but derivative of first derivative. So what is this, bacha? This part is first derivative. Okay, so what is second derivative, sir? Derivative of the first derivative is called as second derivative, sir. Okay, chaliye. Let's move on now. What we have? Find dy by dx if x power x minus 2 power sine x. Okay, let's do this. This question is very important. I'll tell you why. I told you this when I was teaching you in the regular sessions. Whenever you have power form, multiplication, okay, or division also, use logs. Let's see how. So first of all, let's call this function to be y, okay. Y equals to, I take bacha x power x minus 2 power sin x, 2 power sin x, okay. Now in this I'm going to call this function to be, let's say, p, and this to be q. So basically I am supposed to find what bacha, dp by dx, sorry, dy by dx, no, one second, dy by dx, yes sir, dy by dx equals to dp by dx for the first function, then minus sign will come, dq by dx, sir. So what we're going to do, we're going to take them individually as p and q and then differentiate, then club them together like this. Does it make sense to you? Okay, chaliye. So let's do it. Right here, p equals to x power x, apply log on both sides, you get log of p equals to log of x power x, this x will come in front, okay. So it will become bacha x log x. Now you differentiate on both sides, it will become 1 by p dp by dx, and I get this side as, please check, rule of differentiation, product rule is there, so apply that. Differentiate x, it will become 1, keep log x as it is, now take a plus sign, it's a product rule, okay. And now this time you keep x as it is and differentiate log x, it will become 1 by x, log x is 1 by x, cancels. What I'm getting now, please check, I'm getting this dp by dx equals to, I'll move this p on this side, I get here p times of simply log x plus 1, okay. So I can simplify this further, it will become dp by dx equals to, what is p value bacha, x power x 1 plus log x, please check. This is your result for the dp by dx part, okay. dp by dx part, have a look. I hope this is clear, dp by dx part. We also need tq by dx, well, let's just do that part as well. Okay, sir. So what we have right here, q equals to 2 power sine x, apply again same thing as said, log, okay, because of the power, so log q equals to, okay, excuse me sir, okay, log of 2 power sine x will become bacha, sine x will come in front, sine x log 2, sine x log 2, okay. So what I'm getting, please check, I'm getting this as, I'll write one more time because a little messy in the previous case. So log q equals to sine x and log 2. Good news about this step, yes sir, this is a constant, so don't have to worry about that. Differentiate now, 1 by q dq by dx equals to log 2, you keep as it is, sine x will become cos x, okay. So what I get dq by dx equals to, bring this q on this side, please check, it will become bacha 2 power sine x, okay. Then you'll have of course log 2 times of cos x, bacha. Do one thing, put them together and write as a final answer from your side. Please do it, I know you can do this much, right. I have given dq by dx, dp by dx, put in this form, okay. Use this equation number 2, if I write this as equation number, let's say 1, this as equation number 2, this is equation number 3, no. To get the final answer, I'm asking you to do what, put 2 and 3 in 1, that's your answer. Just put it there, no simplification, just put the two values together. Let's move on to next question now. I hope this is clear, okay. Okay, so we have y equal to 500 times of e power 7x, 600 times of e power minus 7x, so that y2, second derivative is 49 times of y. Chaliye, let's do it. Let's find y1 first. So I'll have 500 as it is, constant, e power 7x as it is, times of 7. Won't you agree? E power 7x will remain e power 7x only, but 7 will become, 7x will become 7, no? Differentiate 7x. How much is that? 7 only, okay. Now we'll have 600 as it is, e power minus 7x will become as it is, what I get, minus 7. Let's do one thing, take this minus sign common, okay, sorry, 7 common. What I'm getting now, please check, 500, one second. So 500 e power 7x, I get a minus sign, so minus 600 e power minus 7x. What I have done, I have taken just 7 common, okay, nothing else, not minus 7, just 7 common. Differentiate again bacha to get y2. This is my first derivative, okay, this is my second derivative. What I'm going to do, differentiate again, keep this 7 outside as it is. Now 500 will again remain as it is, constant. E will become same, no change in the exponential function, okay. And again for 7x you have to do the chain rule, right? It will become 7 once again 7. Now there is a minus sign, keep it as it is, 600, it will become same thing, e power minus 7x. What I get, another minus 7, close the bracket, okay. Let's do one thing, take this 7 also common. You get here already 1 7 was there, you've taken one more 7 out. What I have left inside, 500 e power 7x. Over here minus and minus becomes plus, sir, plus 600 e power minus 7x, close the bracket, okay. Now check this out, y2, 7 into 7, sir, 49. What is this bacha? 500 e power 7x, 600 e power minus 7x, nothing but y. So we have proved that, please check. This is nothing but, this whole thing is nothing but y only, right? Proved, sir. Simple question, okay. So as I said, second derivative is also very, very important. Now we have another question on the second derivative. Let's solve this quickly, okay. So y equal to e power a cos inverse of x is there. X is from minus 1 to 1, of course, the domain of cos inverse of x. So that this condition is true, let's do one thing, differentiate it. We have to go till all the way till second derivative, okay. Chaliye, let's apply, sir. First derivative is going to be y1 equals to, it will remain as it is, so e power a cos inverse of x will be as it is. First step is as it is. Now what will happen, chain rule. So again this is a constant, keep the constant as it is. So a cos inverse is what, sir? Minus 1 upon, we just learnt, 1 minus x square, okay, 1 minus x square. Let's do one thing, bring this term on this side. What do you get? Root of 1 minus x square, y1 I get, okay, times y1 I get, equals to, please check, minus a e power a cos inverse of x, e power a cos inverse of x I am getting, okay. We can write this as 1 minus x square y1 equals to minus a, please check, this is nothing but y, sir. So right here y. Now what are we going to do? Squaring both sides. What will have, bacha? Please check. It will become, sir, there will be no root over here. You will have 1 minus x square y1 square. What I have on this side? A square y square. Now find the derivative once again. What I get now? To find the y2. For this part if I am doing, I'll get here, sir, please check. Simply minus 2x, y1 square is as it is, okay. I'm getting over here, plus sign will come, okay, keeping this part as it is, 1 minus x square as it is. Now integrate, sir, differentiate this part, will become 2y1 y2, 2y1 y2, correct now? 2y1, then you have to do for y1 also, it will become y2, chain rule, okay. On the side which I will get 2a, okay, sorry, a square into 2y, excuse me, not 2a, right? It will become a square into 2y, please check, a square into 2y, there will be another y1 also, correct, no? For this y square you are going to get 2y, apply the chain rule again. So I have something getting cancelled, have a look. What is that, sir? One of the y1 from here, cancel with this one of the y1 from here, then this y1 from here, okay, not the entire thing, only this part, okay, only this power part will be cancelled. So what I'm left with is minus 2, okay, they have another cancellation, right? 2, 2 and this 2. So what I'm getting now, please check, I'm getting here 1 minus x square times, I have only y2 left, so right here y2, minus sign is there, this minus x times of y1. Please check, there was 2 y1 over here, y1 square was there, no, I've taken one of them out, it will become only x y1, and if you bring this side over here, you get a square minus y, sorry, minus a square y equal to 0, correct, now same thing is there. If you write in that form, it will become, so 1 minus x square d square y upon dx square minus x times of dy by dx minus a square y equals to 0. Please have a look. Done? This is done. Let's move on to next question now. Okay. Alright sir, what we have? AOD now. So this chapter C and D is over, continuity and differentiability is over. Now moving to AOD now. A balloon, bacha, over here I have taken first question on rate of change. First question on rate of change, sir. Rate of change. Let's do this question. A balloon which always remains spherical on inflation. Spherical means will have volume as, please check, 4 by 3 pi r cube. 4 by 3 pi r. Somebody was asking me, okay, I saw a comment somewhere, that what is the dv by dr? How do you find dv by dr, bacha? Whenever we have bacha dv by dr, no, we don't have to worry about anything. Just simply write this 4 by 3 right here pi 3 r square. To get 3 and 3 cancel, it will become, sir, 4 pi r square. It's a doubt from someone of you. Okay, I think somebody asked this. This is your answer. But in this case, it's not applied. We'll see that later. Don't worry. Not applied in this case. Just somebody was asking me. That's why I wrote it over here. Okay. So dv by dr is very simple actually, but we will deal with something else over here. Let's see what is it. So they've given this is being inflated by a pumping in 900 cubic centimeter cube. Okay, cubic centimeters of gas per second. Okay, so they've given this value, so they've given dv by dt actually as 900 centimeter cube per second. Okay, find the rate at which the radius of the balloon is changing, increasing actually. They're asking, sir, dx by dt is how much? Let's find this. So we have to find what, sir, dv by dt. From here, you're gonna get this as 4 by 3 pi 3 r square times of dr by dt. In this case, we don't have x, actually we have dr by dt. Okay, forgive me for that. The 3 is cancelled. What I'm getting here, 4 pi r square dr by dt. You want to find this part, no? Let's move everything on this side. So I get dv by dt, okay, into 1 upon 4 pi r square equals to dr by dt. Now we have all the values, please check. So we're gonna get dr by dt as, have a look, d by dt is how much, sir? 900 into 1 upon 4 I have, pi I have. What is r value, sir? They have given here 15 square. Okay, 15 square. Okay, so what I get now, please check. I get here 900 into 1 upon, basically I don't have to write into 1, no, 900 upon, please check, it will become, sir, 4 into pi into 15 square, no, so 225 sir. Okay, so what I'm getting now, please check, it will become 800 and again 900, no, only, yes sir, this will be 900 only, sir, please check. What I'm getting now, 1 by pi actually, 1 by pi is dr by dt, right? So it will be centimeter per second, centimeters per second. Please check. 200 into 4 is 800 and 25 into 4 is 100. It will become 900 only. Please check. Answer is 1 by pi centimeter per second. Done. Next, what we have, increasing and decreasing functions. How do you find that, sir? Very simple. For any given function, first step is to find the derivative. Once you find that, put the derivative function that you got equal to 0. Why are you doing that? To find my critical point. I'll repeat myself. Any function is given to you, asked for increasing and decreasing interval. Okay, do one thing, find the derivative, put it equal to 0 to find the critical point, and then plot on the number line and see the sections which is positive, which is negative by putting in the random value or apply the wavy curve. Anything works. Okay, have a look here. So if you have the derivative greater than 0 means increasing, derivative greater than 0 means increasing, less than 0 means decreasing. Okay, how do you do that? Derivative, critical point, and look for the different intervals. Okay, let's have a look. Questions. Find the intervals in which the function f given by fx equals to 4x cube minus 6x square minus 72x plus 30 is strictly increasing. There's a word over here, very important. Strictly increasing, sir. There's a difference. I'll show you. Do not worry. So first find the derivative. First step is to find the derivative. What I get? 12x square minus 12x, right? Minus 72. Take here 12 common. What I get? X square minus x minus 6. Put it equal to 0. I get 0 equals to x square minus x minus 6. Factors are x minus 3 and x plus 2. How come, sir? Please check. X into x is x square, x into 2 is plus 2x, x into minus 3 is minus 3x, makes it minus x over here, and minus 3 into 2 is minus 6. Okay, so from here if you compare, you're getting two critical points, x equals to minus 2 and 3. Put it on the number line. I get here minus 2 over here and 3 over here. Coefficient of x, bacha. Coefficient of x is positive, means start from plus, minus and plus. If you don't want this method, what you can do is apply. Put the values after 3 in both the values. Check for the derivative fx. Do one thing. Take a value more than 3. It will become 4, sir. 4 minus 3 is positive. Positive, sir. It means derivative of positive. That's why positive. Here, it will get negative. Here, you get positive again. What is this point, sir? Negative infinity. This, sir, plus infinity. Okay. So, we're looking for positive, no? Yeah. So we are getting f dash of x is increasing, not equal to, only greater than 0 in two intervals. Okay, where is to where? Negative infinity to minus 2. Keep it open, sir, not 0. Open, sir. Okay, and open from union from 3 to infinity. Okay, there's open bracket over here. If they were asking us for increasing, then we'll keep here closed and closed. But they're asking what? Strictly increasing means this cannot be 0, only positive, right? This cannot be 0, only positive. I cannot take equal to 0 over here. If they were asking only increasing, I can put equal to 0. But what they're asking? Strictly increasing. I cannot put equal to 0. That's why no equality over here. Because at minus 2 and 3, what will happen to the function? Derivative. It'll be 0, right? Okay. So my function is going to be increasing in this interval only. Have a look. This is my answer, okay? This is my answer, sir. Have a look. Next, sir, we have proved that the function f given by fx equals to log of cos x is strictly increasing in pi by 2, pi. A very interesting question. You'll see now. So what we have, find the first step as f dash of x. What we get? Log derivative. So 1 by cos. Now derivative of cos from the chain rule. I get minus sine. What I get now? Minus tan x. Very interesting question. So we have two parts over here, minus tan, okay, so that is my derivative, okay, with the minus sign. Very, very important. Okay, chaliye, draw the curve of the tan x. And from where to where I want? Pi by 2 to pi, right? So we know this is the curve of tan. This is your pi by 2, right? This is a pi by 2. This point is pi by 2. Again, it will become like this only. Please check. It will be your pi, sir. Okay, now what will happen? No, I'm telling you the mistake of yours. What will happen? You will look at this graph. This is the contains, no? What is this, sir? This is the condition for pi by 2 to pi. You will say, sir, this is negative, sir. This is negative, sir, less than 0. Hence what, bacha? Or it will be basically increasing in nature or decreasing in nature. You conclude from there. Don't do that. Don't do that right away. Okay, just understand that this is not function given to you. This is just a derivative. What is this, sir? They've given here tan of x is less than 0. Tan of x is less than 0, not greater than 0. Tan of x is less than 0. Correct, now? This, please check. In this interval, tan of x is, sir, less than 0. No, it's below the x-axis, so less than 0. Okay. What are we looking for, sir? We are looking for, have a look. From here, we can see the graph tan x is less than 0. Then what happened to this, bacha? Minus tan x? It will become greater than 0. It will become greater than 0. Okay. What is this going to be? F dash of x only, na? Please check. What is the minus tan x, sir? F dash of x. What is that? Greater than 0. Therefore, we can say fx is increasing in the interval pi by 2 to pi. Tan x is negative, that's why minus tan x will be positive. Tan x is negative means minus tan x is positive, hence derivative is positive, hence increasing in the interval pi by 2 to pi. Excellent question. Okay, excellent question. Chaliye. Next now, maxima minima, the last part of your AOD. That's simple, sir? Yes, that's simple. What we have? First derivative test, sir, very simple. No, you find the first derivative. Why we do that, sir? To find the first thing is critical point. From critical point, what do you do? Plot on the number line and look for the sign change. Sign change. How do you look, sir? Please check. If you have this, what is this called, bacha? Minima or maxima? Minima, sir. Draw the slope over here and draw the slope on this side. What is the slope, bacha? Obtuse angle. This is obtuse angle. What is this slope, bacha? Acute angle. It means over here I have negative, over here I have positive. I'll repeat myself. Slope is changing from minus to plus. This is minus, this is plus. It means local minima. Whenever you have minus to plus, whenever you have, please check. Whenever the slope, the derivative is changing from minus to plus sir. Sign change from derivative. What is derivative represents? Slope. Slope is changing from minus to plus, local minima. Ulta. What is the slope, bacha? Like this. Slope over here, like this. How much is this, bacha? Obtuse angle, so negative. What is this, bacha? Acute angle, so positive. How can, sir? Tan theta for acute is negative. Sorry, positive. Obtuse is negative. Second quadrant, bacha. Acute angle means first quadrant, sir. I'll repeat myself. Acute angle means first quadrant. Obtuse means second quadrant. Second quadrant, what happens to tan? Negative. Okay. It means obtuse angle, so slope is what, sir? Slope is nothing but tan theta, no? dy by dx is what, bacha? Tan theta only, right? Okay. So negative. Over here, positive. So plus to minus, what is this point called as? Local maxima, no, sir. This is a peak. Local maxima. Sign change from plus to minus is local maxima. Sir, too confusing. Don't do that. Okay, don't do that. If you don't want, don't do the first derivative test. Until and unless they tell you in the question, use the first derivative test to perform any, task that they asked you. They've given a task to you and they have specified that use first derivative test, then only you use it. Otherwise, simple, sir. Go with this. Go with this. Blindly you go. This is easy, no? First find the first derivative and get the critical points equal to 0. You get the critical points, and from that what are you going to do? Find the second derivative, sir. Find second derivative. If it is coming as positive means local minima. What, sir? Means find the second derivative and the critical points that you got, no? Put the critical points in the derivative. If it is coming as positive, those point is critical minima. If it, local minima, forgive me. Coming as negative means local maximum. Sir, ulta, sir. Yes, ulta, sir. If second derivative at that point is, I'll repeat myself. Second derivative at that point is negative, local maxima. Second derivative at that point is negative, local maxima. Second derivative at the point is positive, local minima. Local minima. Please check. Positive means local minima, local maxima. I know you know this, right? Just revising, just helping you to revise this part. Okay, let's move on now. Find two positive numbers whose sum is 15 and sum of whose squares is minimum. Alright. Take bacha first number to be x. What is the other number going to be? 15 minus x, na? Sum is 15, right? So one of the number is x, other number is 15 minus x. Works? Okay, sir. Sum of the square. Take bacha this as sum of a square means x square plus 15 minus x the whole square. Okay, we want to minimize this, right? So first find the derivative. It will become 2x. It will become 2 times of 15 minus x times of minus 1, na? How come, sir? For this you're gonna apply this 2 times of this will come in front, and then 2 minus 1 will become 1 only. Then apply the chain rule. For 15 you'll have 0. For x minus x you'll have minus 1. Okay, sir. What I'm getting, please check. Very interesting question. 2x and I have over here plus 30. Minus 30, no? Excuse me, sir. My mistake. Minus 30, bacha. Minus 30 over here. Minus 1 into 15 into 2. Minus 30. Minus 1 into minus x into 2. Plus 2x. Okay. So this is going to be 0. To find what? The critical point. What I'm getting now, it'll become, so 30 equals to 4x. So x equals to 30 by 4. X equals to 15 by 2. Only 1 point, no bacha? Only 1 point. Okay. Alright, we have only one critical point. If you want, you can apply the second derivative over here as well. What you're gonna get, please check. You're gonna get this as this will be coming as 2. Okay, and this part will be what, bacha? It will be a negative number, no? Okay. Please check. It will be, sir, 2, and you'll have over here as the minus sign is there. It will become again a 15 minus. So it will be, there's a constant, of course. 2 is there. 2 will be left. It will be 0. Okay, it will be 0, and it will be minus 1. What I'm gonna get? 2 plus 2. How much is that? Positive. Positive means minima. Positive means minima. It means, sir, this is what, bacha? This is your d square s upon dx square. Second derivative is coming as positive means this point is going to be minima only, no? So how the point, bacha? We don't have any variable over here. So how can you put this value? There is only one point. It's going to be point of minima only, because derivative is going to be positive straight away. Okay, what is the number going to be? The numbers are x equals to 15 by 2, and the other number is of course 15 by 2 only, because the sum is, sir, how much? The sum is 15, no? So numbers are 15 by 2 and 15 by 2. Okay, please check. Done. Find the local maxima, local minima of the function given like that. Excellent question. Excellent question. Not a PYQ, but excellent question. You'll see how. Okay. Local maxima, local minima. Function is given. First thing is to find the derivative, sir. That's what you've taught us. That's what we're gonna do. That's your response. That's your response, sir. We have learned something. We're gonna apply that only. First thing is that step. Apply this. Sine will become cos. It'll become, sir, minus of minus sine. I get here cos x plus sine. Put it equal to 0 to find the critical point. What I get? Minus sine x equals to cos x. Basically, tan x equals to minus 1. It means what? What is the value of x, bacha? It can be either in the second quadrant or in the fourth quadrant. How come, sir? Here the tan is positive, here tan is positive. First quadrant, all positive. Third quadrant, tan and cot positive. It means second or fourth quadrant, the angle has to be in. Can I say only second? No. We have to take both the cases, na? So actually, you're going to get this angle x to be. Please check. Pi by 2 plus pi by 4. Why like that, sir? Because tan at pi by 2 will become to cot. It will become same, no? It's complementary function. Okay? And so it will become, sir, pi by 2 plus pi by 4 will be, sir, 3 pi by 4, no? Please check. Pi by 2 plus pi by 4. Pi by 2 plus pi by 4, right? How much is this? 4 is there. Please check. I get here 2 pi plus pi. 3 pi by 4. Correct only. What about this, bacha? It will become 3 pi by 2 plus pi by 4. For this quadrant, we'll have 3 pi by 2 plus pi by 4. It becomes a 7 pi by 4, no? 6 plus pi. So you'll have two values. 7 pi by 4, sir. These are the critical points. 3 pi by 4 and 7 pi by 4. Difficult? No, sir. Second quadrant, fourth quadrant. This is pi by 2, no? Sir, this is pi by 2. What is this, sir? Sir, this is 3 pi by 2. Right? 3 pi by 2 and pi by 2. So pi by 2 plus pi by 4 is first one. 3 pi by 2 plus pi by 4 is second one. Okay. Now after this, what I'm getting, please check. I have to find second derivative now. Let's do that. F double dash of x. What I'm getting now, from here we can do cos will become, sir, minus sine. And this will become, sir, simply plus cos. So what I'm getting, cos x minus sin x. This is nothing but cos x minus sin x. Cos x minus sin x is my second derivative. Apply for both the points to check minima and maxima value. Let's apply, sir, for first point. F double dash of 3 pi by 4. What I get? Sir, which quadrant is this? Which quadrant is this? Second quadrant, na? Sin will be positive, bacha. So cos will be negative. So I get here minus 1 by root 2. What about this, sir? You'll have a minus sign of cos. This is a minus sign. This is a minus sign. What about sin, bacha? It'll be 1 by root 2. I'll repeat myself. Don't worry. I'll repeat myself. Think about it. I'm taking angle as 3 pi by 4. Which quadrant? Second quadrant. Second quadrant, sin is positive. So this will become, sir, 1 by root 2. How in the root 2? Sir, pi by 4. Sin 45 degrees. Okay, what will happen to this, bacha? 1 by root 2 only, no? Okay. So 1 by root 2. There's a second quadrant, that's why positive. There's a minus sign outside, that's why negative. Cos is negative, that's why simply minus. What I get? Less than 0. Why not value, sir? Does it matter to us? No. Not this value is mattering. Okay, this is less than 0, sir. So your f double dash of x, basically 3 pi by 4, is less than 0 means point of 3 pi by 4 is point of local maxima. Sir, less than 0. Yes, I said that. Second derivative is negative means local maxima. Hence, the function value you find now, function value at 3 pi by 4 you find now. Please check. Cos of this value, how much is that? How much is that? Please check. Minus. What I have? Okay, not this, excuse me. That's not function value, sir. You make mistakes, sir. Sorry, bacha. Function is over here. Function is over here. Sine of 3 pi by 4. Sine of 3 pi by 4 minus cos of 3 pi by 4. How much is this? 1 by root 2. How much is this? Minus 1 by root 2. Why, sir? Second quadrant. Angle is in second quadrant. Cos is negative. That's why minus 1 by root 2. Answer will be 1 by root 2 plus 1 by root 2, giving me the value to be 2 by root 2. Hence, sir, f of 3 pi by 4 is nothing but simply root 2. This is your local maximum value. This is your, please check, local maximum value. So I'm going to write it over here. Local maxima. Where, bacha? At 3 pi by 4. Value of the function is how much, sir? Root 2. How much, sir? Root 2. Everything is clear. Of course it is clear, sir. Please check. Function is root 2 and this is the point of local maxima. Same thing you do for 7 pi by 4. What are you going to get? I'll tell you. I'm not doing it. I'll tell you. I'm telling you. Local minima you'll have at 7 pi by 4 and your function value will become, please check, minus root 2. I'm asking you to solve this. Please solve this part, sir. I'm requesting you to solve this part. Solve the second part. Means this part I'm asking you to solve. Please solve it. I know you can solve it. Just put it over here. Same way I applied. What will happen, sir? This will be positive, negative like that. Sign will be negative over here. Cos will be positive there. So you'll have this as negative. It will become positive. This will be positive. So derivative will become, second derivative will become positive. Hence local minima. Sign is negative, no? Minus of minus, plus. Cos is positive. Whole thing is positive. Second derivative is coming as positive. Hence local minima. And again, if you find the value, you're going to get this as minus root 2. Please solve it. Okay. I'm expecting from you to solve it. Please do not let me down. Now, sir, second chapter is also over. We are moving on to the best chapter of mathematics, integrals. Best, sir? Yes, best. It is simple, sir. Not all the time. Sometimes it is challenging, but we have to do it high weightage. Okay. So simple formulas are there. For constant, we get x introduced over here. Okay. Whenever you have x power n, you add this with n plus 1 divided by the same thing. N plus 1. Okay. Whenever you have 1 by x, ln x. Okay. 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 What is this, sir? E power x is nothing but e power x plus c. What is c, sir? The constant of integration. Okay, the arbitrary constant. A power x, bacha, integration is going to be a power x ln a. A power x ln a. What we have next? Sin x, sir, is minus cos x. Some formulas over here. Cos x is sin. Sec square is tan. Cos x square is minus cot. Sec x tan x is sec x. And sec x, cosec x cot x is minus cosec x. Please check. What else we have? Inverse trigonometric integrals we'll be having. Please, as I said, only these three are very, very important to you. For tan inverse, sin inverse and sec inverse. Okay. So again, by parts. Now this is your one of the most important thing in for exam point of view. Why, sir? Question will come on this? No. I'm not saying the question will come on this. I'm saying you will have to use this multiple times. Whether in the case of special integrals, in the case of normal substitution questions, this can be used. That's why remember this without fail. This is a property called as ILET, inverse logarithmic algebraic trigonometric exponential. This is used for preference order of the function. Okay. So if I'm taking this as first function, okay, first function what you're gonna do? Keep it as it is. Integrate the second one. And check this out. This was derivative, no? Integrate the second one minus integral of first function differentiation, so u dash. Integrate the second one, so v. Then integrate the product. Okay. Don't worry. Please check here. X, no? X kept as it is. Integration of e power x. Okay. Minus sign. Integration of x derivative. How much is that? 1, sir. Derivative of x is 1, sir. E power x remains e power x. Again, just simplify this. Get the answer. Okay. What next we have? By substitution, bacha. Okay. One of the most important part about this question is the question will not come on this directly, but it will be used everywhere. It will be used everywhere, you'll see. Okay. Now understand this. The best way to find the problem for student is actually to figure out what to substitute. Okay. How to pick the right substitution. So I have given you a list of substitutions actually with the help of trigonometric functions. Okay. Logs. All of that is given to you. But if you want one hint about how to pick your right substitution, what gonna do now? Look for derivative in the function given to you. If you can find the derivative of any given function, take that function to be your substitution. That's simple as that. Okay. Please check. Over here, I can see, sir, 2x is the derivative of x square. It means x square will be your substitution as t. Yes or no? What is substitution, bacha? X square equals to t is my substitution. Please check. Okay. Over here, I can see this is nothing but my derivative of tan inverse. Okay. Or in this case, we don't need that. Direct answer is there. Direct answer, bacha. Okay. Please check. What else we have? First question on this. Sine inverse of cos x. Integration question, bacha. We'll have fun now. Okay. Let's solve this. Sine inverse of cos x. How do you solve it, sir? Sir, so difficult, sir. So difficult, sir. How can we even solve this question, sir? How can we even solve this question, sir? How can we even expect this to solve from our side? Sine inverse of sine. Gone. Gone. Pi by 2 integration. Pi by 2x. X integration. X square by 2. Done, sir? No. Add plus c. Now done. Yes? Yes. Moving on. This kind of question can be asked in MCQ. Not very big question, no? Simple question. What we have next? Special standard integrals. Very important. Very, very important. Okay. Dx upon a square plus x square can be asked in derivation also. I have done it in my sessions. Okay. So please go ahead, watch my sessions for long questions. Okay. I have done in the model paper also. Wherever the question was this, I have done this. What are you going to do? Take x as sir, what? Tan theta, a tan theta. I'll tell you over here also. Just a help from my side. Okay. But give me, just your comments, sir. Thank you for the help in my derivation of standard integrals. You'll do that. You can say thanks for me. Okay, chaliye. What are you going to do? For this question, sir, you'll take x as a tan theta. A tan theta. Okay. Now you're going to take the differentiation. It will become what? A sec square theta over here. And you'll have what, bacha? You'll have over here as a square sec square theta again. It'll become 1 by a d theta. Integrate. You're going to get 1 by a theta. Theta is what? Tan inverse of x by a. Done. Over here, what are you going to take? X as sine theta. X as sine theta. Okay. Differentiate over this. Please check. All right. What about this, sir? Sir, I told you x as a sine theta. What about this, sir? Are by partial fraction, bacha. Partial fraction, balak. You can solve this. Yes or no? Please check. 1 upon x minus a into x plus a. Apply the partial fraction to get this coefficient as 1 by 2a, 1 by 2a. This will be your answer. Agreed or not? Yes, sir. Okay, this is done. I've given the list of the formulas again. This is very important. I've taught you this part. Now remember this. I should explain you this way. 1 second. Write px plus q equals to a times of derivative of the denominator, bacha, this part. ax square plus bx plus c. X square plus bx plus c. Remember this. And plus b. Compare this and get the values of a and b, and then replace px plus q from in this form. So first find the value of a and b after comparison of this. Doesn't look very neat. I have to write this again. Very, very untidy. Okay. A times of dA by dx of ax square plus bx plus c. Okay. If you're not sure over here, do one thing. Just open the NCERT for 2 minutes and check it right now. Okay. Questions. If questions are coming on this, you have to solve this. I know you can. Okay. Chaliye. Let's move on. Let us move on, sir. What we have? Find the integral of 1 upon x square minus a square. Extend right now. Extend just right now. Okay. Okay, sir. Let's apply this 1 upon x square minus a square as 1 upon x minus a and x plus a. X minus a and x plus a. Okay. One thing is to write this directly like this. 1 by 2a and 1 upon x minus a minus x plus a. I can write it like this also directly if you can get. How, sir? Take this x plus a will come over here, no? What are you going to get? X plus a over here minus x minus a, right? Upon this whole thing will come same thing. X minus a and x plus a. What are you going to get? X and x cancel, you'll have 2a over here. That's why I'm writing this 2a over here. One way to write this, other way, I'll tell you the other way also. Don't worry. Do not worry about that. If you are confused, how did I write this part? No worries, sir. I don't want to confuse my students. Okay. Chaliye. Let's do one thing. Apply the way we know. Partial fractions they can apply. Write it like this. 1 upon x minus a times of x plus a equals to a upon x minus a plus b upon x plus a. Solve this, you're going to get a as 1 upon 2a and you're going to get b as minus 1 upon 2a. Trust me. Solve this. You can solve this, no? A times of x plus a times of plus b times of x minus a, right? Okay, solve this, no? Solve this, bacha. Compare the coefficient of numerator to get value of a and b by putting x as minus a and plus a. I've done this question for all of you. Please do that, okay? Once you do this, what are you going to get? Integration of this 1 upon x minus a, x plus a. Not neat. 1 second. 1 second, sir. X minus a, x plus a dx will become, bacha, please check. I have 1 by 2a common na. Integration of what I'll have? 1 upon x minus a dx and minus x plus a dx. Again, this also integration is there, okay? What I'm getting now? Simply 1 by 2a is there, okay? And I'm getting ln of x minus a minus ln of x plus a. Again, there's a plus c, of course. So I'm getting here 1 by 2a ln of x minus a upon x plus a plus c. This is your answer. Please check. This is your answer. Please check. Done? Okay, done, sir. Let's move on now. Find the integration of x square upon x power 6 plus a power 6. Can we solve it? Of course we can, sir. Let's see. As I said, we're going to use substitution over here. How to look for it? We have x square over here. It means it has to be in terms of x cube. Then only if you differentiate, you're going to get this as x square. I told you, look for derivative. What's the derivative of bacha? For which function I can have derivative in terms of x square? My question is, for which function I can have derivative in terms of x square? The function has to be of the power 3. X cube, if you take the derivative, will become something times of x square. 3x square basically. So take this as x cube as basically t. What will happen? 3x square equals to dt by dx. What I get now? X square dx will be nothing but dt by 3. Use this over here. So I will have, please check, 1 by 3 dt upon root of, please check, x cube the square, no? It will become, sir, t square. X is x cube the square. It will be x cube ka square. Then what will have for this? A cube ka square. What I get? 1 by 3 log of t square. Okay, no, sorry, not t square, simply t. Not t square, simply t plus the same root. Okay, plus the same root. T square plus a power 6, bacha. You have, of course, plus c over here. I get this as 1 by 3 log of, have a look, x cube, t is x cube plus root of x power 6 plus a power 6 plus c. Let me know if you got this right as well. Okay, chaliye. Moving on now. Simple question, very simple. Okay, what we have? Integration of x square plus 2x plus 5 dx. How do you solve it, sir? Okay, I can make this change over here. X square plus 2x plus 1 plus 4 dx. Combine these together. Writing 5 as 1 plus 4. It will become, please check, it will become, sir, x plus 1 the whole square plus 2 square dx. Okay. So root of x square plus a square. What I get now? I get here x plus 1 by 2. Okay. Same root will repeat. What is there? X square plus 2x plus 5. Okay. Then what I have? Plus a square by, so 4 by 2. 4 by 2 I have. Okay. A square is what, bacha? A square is 4 only, no? So 4 by 2. Again, what I'm going to get? Log of, please check, x plus 1. Then will come again same root. Please check. X square plus 2x plus 5 plus c. Plus c. This is your answer. Have a look. Okay, plus c. There's a log over, there's a plus modulus over here. 1 second. There's a modulus over here. 1 second, sir. I can rewrite this. Okay. Okay, this is your answer. I hope this is clear. This is your answer, sir. Okay, clear. Let's move on now. Integral by partial fraction, sir. Okay, integral by partial fraction, bacha. Okay, I already done this one of the question over here. I think somewhere I did right over here. Same thing I've done over here. Okay, use of this I've taken already. So please check. Same approach is there. We'll take something. Please check. A upon x minus a, b upon x minus b. If we have whole square, I can write like this: a upon x minus a plus b upon x minus a the whole square. And again we have, if like this, we cannot factorize it. Ax plus b upon x square plus a square. Okay, chaliye. So you can see here the word is irreducible. Okay, what we have, can you integrate this? I will not do this for you. You have to do it from your side. Okay, please check. Can you do it? Of course you can do it, sir. Or let me do this question. Okay, I will give you one as of the question as homework. So first of all, you take here e power x as t, sir. E power x as t, bacha. It will become t upon 1 plus excuse me, differentiate, no, it will become, sir, e power x dx equals to dt, sir. So not t, it will be dt over here, and 1 plus t times of 2 plus t. Factorize this, what are you gonna get? Integration of 1 upon, first you have to apply the partial fraction, right? Apply the partial fraction, right? 1 second. Okay, we'll do it later. We'll do this part later. Let's deal with the integration part later. Right now, let's use the partial fraction part. So I'll have here 1 upon 1 plus t times of 2 plus t. Please check. It'll become a upon 1 plus t plus b upon 2 plus t, giving me a times of 2 plus t plus b upon 1 plus t. Okay, we have the same denominator. I can just ignore that. We have same denominator. I can just compare the numerator. Put here t equals to minus 1. What am I gonna get? I'm gonna get here 1 equals to a times of 1, right? So I have a equals to simply 1, sir. Simply 1. Now put here t equals to minus 2. T equals to minus 2. You put, what are you gonna get? 1 equals to, bacha, there will be 0, no? It will become b times of minus 1. Hence b is nothing but minus 1 only. Please check. B is nothing but minus 1 only. Okay, once I have this, I can write this as integration of, please check, integration of dt upon, first is 1, right? So dt upon 1 plus t, okay, and I have a minus sign. I have minus dt upon 2 plus t. Okay, what I get? I get here ln of 1 plus t minus ln of 2 plus t and plus c, of course. I'm getting here ln of 1 plus t upon 2 plus t. Log a minus log b is nothing but log of a by b plus c. It becomes, so, ln of 1 plus e power x upon 2 plus e power x plus c. This is your final answer. Please check. Final answer, please check. Okay, t is nothing but e power x, no? I've written same thing over here, so done. Simple. Moving on, we have another question like this. Find the integral of 3x plus 5 divided by x cube minus x squared minus x plus 1. How do you solve it, Richa? Of course, you have to apply the partial fractions. Okay, but before that, we have to make, sir, factors over here. We have to make factors over here. How do we do that? I can see x square is common in this place, and I can take minus 1 common over here. Something will come out of this. So I can write this integration I, please check, like 3x plus 5 upon, I take in the first two terms x square common, I'll end up with x minus 1, okay, and then I take minus sign common, I end up with again x minus 1, right? So I'm taking actually minus 1 only common, na? So when I say minus sign, I mean minus 1 only, right? That's just how you say it. What are you gonna do now? Please write it as 3x plus 5 divided by, take x minus 1 common, you have here x square minus 1 dx, x square minus 1 dx. Okay, now how do you make, bacha, factors now? Can you do this? Please check. So I can write this fraction once again in this format. It'll become 3x plus 5 upon x minus 1, the first factor. The other one is x square minus 1, right? That is nothing but a square minus b square. So it'll become x minus 1 and x plus 1. Okay, so now what I can do is I can rewrite this as, please check, 3x plus 5 upon, write x plus 1 first. So I take this x plus 1. What is this? So same thing, no? So right here as x minus 1 the whole square, x minus 1 the whole square. Now we can make the partial fractions for this. Okay, so for this, bacha, become a upon, please check, x plus 1 plus b upon x minus 1 plus c upon x minus 1 the whole square, x minus 1 the whole square. Correct. Now if you compare this with the coefficient of this, no, what we have on this side, please check 3x plus 5 upon this whole thing, x plus 1 and x minus 1 the whole square. If you put the values, just take LCM over here and put the values as x equals to 1 minus 1, okay, you'll get equations in ABC, and then you solve it, bacha. You're gonna get the values for ABC as, I write it for you, you have to do the steps. A is going to be 1 by 2, B will come as minus 1 by 2, and C will come as 4. C will come as 4. Okay, now if you do that and integrate later, what will happen? Please check. So my integration will actually turn out to be, after this, finding the value. How if you're finding it? Take the LCM over here, right? We've done so many questions like this. Take the LCM, same thing will come. You will have a times of x minus 1 over here, the whole square. You will have b times of x minus 1 into x plus 1. Over here you will have c times of only x plus 1. I'll repeat myself. A times of x minus 1 the whole square you'll have. On this side you'll have x minus 1 into x plus 1. For this side you'll have only x plus 1. C into x plus 1. Then you substitute the values and get a, b, c as 1 by 2, minus 1 by 2 and 4. Okay. Now this integration will transform into, please check. What I have, integration of 1 by 2, 1 upon x plus 1 dx, of course. Next we have, for b, we have minus sign, so right here minus 1 by 2, integration of 1 upon x minus 1, again dx. The last one, plus 4, we have integration of 1 upon x minus 1 the whole square dx, right? This is very, very simple. Please check. I will become 1 by 2 ln x plus 1 minus 1 by 2 ln x minus 1. Okay, what else we have? For this part, which will become plus 4, and this is nothing but, please check, x minus 1 power minus 2, right? Dx. Can you integrate this part? It will become minus 2 will come. Okay, so no, not minus 2. You have to add no for this. So basically, if you remove the integration part over here itself, if I remove the integration over here itself, what will this be? Please check. It will become minus 2 plus 1 divided by minus 2 plus 1. Of course, there will be a constant c. Okay, so my integration will turn out to be, please check, I'll have 1 by 2 common over here. 1 by 2 ln log a log b, subtraction is there. So ln x plus 1 upon x minus 1. This is clear. Okay, what else we have, sir? For this part we have, minus will become, no, minus 2 plus 1 is minus 1. So minus 4, and this will be x minus 1 power minus 1, no? So minus 4 by x minus 1 in the denominator. I'll repeat myself. X minus 1 power minus 2 plus 1, which is how much? Minus 1. Power is negative. I can take it in the denominator, no? X power minus 1 is how much, sir? 1 by x power x minus 1. Anything to power, let's say I have y power minus 1. How much is that? 1 upon y. Same way. X minus 1 power minus 1 I have taken that in the denominator. Comes with plus c. Comes with plus c. This is your final answer. Please check. Okay. This is your final answer. Okay. Chaliye. So this is clear, right? I hope this makes sense to all of you. Okay. Have a look. This all is visible to you, right? No problem. Okay. So moving on now. We have some definite integral also to deal with. The properties are very, very important. The fundamental theorem of calculus, if you know how to do it, sir, if you, after integrating it, substitute the limits in the fashion upper limit minus lower limit, sir. So function value after the integration, add the upper limit minus the function value of the integration at the lower limit. So fb minus fa. Okay, the upper limit is b, the lower limit is a, sir. Properties, if you remember, reversal property means I can reverse the limits using what? A negative sign. I can reverse the limit using a negative sign. So it was here a to b, here it is b to a with the help of minus sign. Okay, chaliye. Now we can add this. Okay, basically what you can understand, no, from here you can understand. If I have a given integration, different integration from a to c, I can break into any amount of time. Okay, but remember this, the first one has to be a and the last, so basically the first integrals lower limit has to be a and the last integrals upper limit has to be c. Okay, otherwise if you want to use this additivity, okay, what are you going to do? Just make sure that this is always common, sir. 1 second. Make sure that this is always common, sir. So upper limit of the first integral should be equal to lower limit of the second integral, and of course function has to be same. Okay, so you can split this whole limit a to c into multiple of times. Okay, I can write a to b and then b to d, then d to c. That also is okay. I am saying what? Right here a to b then whatever it is, then b to d, whatever it is, then you write again one more time d to c. Will be same, actually will be same. Okay, what we have? Even odd functions without definition, right? So for even function, what happens, sir? Minus a to a is the integration is there, it will become 2 times of 0 to a fx dx. Okay, a lot of questions are there, not only questions, derivation comes for this formula as well. Okay, for this property derivation is been asked. Okay, I have taken a question like this, I'll show you, don't worry. Minus a to a fx dx equal to 0 when fx is the odd function. Fx is the odd function. How do you check, bacha, odd and even function? I can write it over here for you. Even function, how do you check, sir? If f of minus x is nothing but f of x, we call the function to be even, and when we call the function to be odd, when f of minus x is nothing but negative of f of x, that is called as odd. So that's how we check it, actually. Before going to the question, no, before taking up anything, we check the questions, the given function in this format, and then we choose the respective property. Then we choose the respective property for even or odd. Done. Chaliye. Next, what we have to prove that 0 to 2a fx dx, 0 to a fx dx plus 0 to a f of 2a minus x. Okay. Chaliye, let's solve this. Let us solve this, sir. Okay. So what we have over here, I'll take this bacha LHS again. What we have, please check. I have here 0 to 2a f of x dx, right? I can write this in this form of picture, 0 to a, excuse me, the property that we learned right now, additive property. Okay, 0 to a fx dx plus a to 2a, we can do that, no? 0 to a fx dx plus a to 2a fx dx. Will you not all agree with me? Same thing. I've broken this integration, the limit from 0 to 2a to 0 to a and a to 2a, nothing else. Okay. Now, if you check here, this part over here, one second, this part over here and this part over here is same. Means I don't have to worry about this part. If I can prove this something somehow to be equal to this, means my job is done. Okay. So I'll just take this part. This part I'll take over here. What I have, a to 2a, and then I have f of x dx. Now you can see limit, don't forget about the limits right now. You can just see, sir, compare this function with this function, sir. Of course, I have to take a variable in such a way that 2a minus x should be there. Okay, so what are we going to do? Substitution over here. Take bacha x equals to 2a minus t. 2a minus t. 2a minus t. Please check. X equals to 2a minus t. When you do that, what's the derivative, sir? It will become dx equals to minus dt. Minus dt. What about your limits? Please check. Your limits will become, have a look, it will become, sir, if I take x equals to, what's this value? A. What happens here? Please check. In this part, you write a equals to 2a minus t. Bring this t on this side and bring this a on this side. I get t equals to a. This is for lower limit, sir. This is for lower limit, sir. Please check. For lower limit. Okay. When x equals to a, I'm getting t as what, bacha? T as, excuse me. When x equals to a, I'm getting t as a. Yes, that's right. Okay. What next we have, sir? For the upper limit, I'll solve it again over here only. For upper limit, please check. What is it given? X equals to 2a is there. Right? X equals to 2a is there. X equals to 2a. Okay. X equals to 2a we have. So write this as 2a equals to, what is it? 2a minus t, no? 2a minus t. What we're gonna get? T equals to 0. I'm gonna write the integration of this part again. Please check. I'll write this part again. It'll become, the integration will check first. When it was lower limit, we got as bacha a only. So we write this as a. When x was a, t is a. Upper limit, when x is 2a, t is 0. So right here 0. Okay, 0, sir. What we have, x will become, please check, 2a minus t, and dx will become, sir, minus dt. Okay. Now this minus will, bacha, help me change this limits. We have a minus sign here, no? I can reverse the limit from 0 to a and make this positive. So 0 to a f of 2a minus t dt. Correct, now? This minus makes it again reversing the limits. Now simply what you're going to do, substitute t as x, t as x. When you do that, what are you gonna get? Please check. Our job is done actually. We're getting 0 to a f of 2a minus x dx. Please check. This is my part 2. If I call this to be part 2, right? If I call this to be, let's say, part 2, okay, this to be also part 2 only, okay. So please check. Actually we have got this part equals to 0 to a f of 2a minus x dx. Same thing. So if you put back this second part in this given expression, what are you gonna get? Same result. Hence proved, sir. What we're getting? Equals to RHS. Okay, what we get? RHS equals to LHS actually. Please check. Done, no? Right? This is clear? Okay, very simple. Let's move on now. Okay, this bacha, as I said, this is also a given questions that can be asked. Not like this. What they do is, no, they give you this property to prove and they give you a question on it. Okay, the question will be very simple, no? You have to just use the function as f of minus x. So they'll give you a function fx, right? What are you gonna do? Find the f of minus x. If it's coming as, let's say, odd, you're gonna get minus f of x. So for odd function, what will happen? What will happen for odd function? It will come out as 0, so it will come out as 0, so okay. Even means we'll see the integration, not a problem. 0 to 2a, 0 to a, 2 times of fx dx. Okay, chaliye. So what we have now? Have a look. How do you solve it, sir? So first of all, you define it like this same way. Minus a to a f of x dx becomes equals to minus a to 0 f of x dx. Okay, and we have here plus 0 to a f of x dx. In this case, bacha will deal with only this part. Let's call this to be part 1. Why not this part, sir? This is same, no? 0 to a f of x dx. Not a problem there. Let's take this. Same approach is there, bacha. Minus a to 0 f of x dx we have now. Let's do one thing. In this function, you apply x equals to minus t. What are you gonna get? You're gonna get dx equals to minus dt. Check for the limits now. For lower limit, bacha, when x is equals to minus a, you get t equals to a. When x equals to upper limit 0, t equals to 0 only, right? 0 only, right? So this will become, please check, a to 0 f of minus t, again dt will come, f of minus t, again dt will come. What I'm getting now? I'm getting here, no, sorry, not minus dt, we'll have minus dt, no, sorry, there's a minus sign, of course, outside. Okay, so it'll become, sir, change the limit again, it will become 0 to a, there will be a positive sign over here now, f of minus t dt, f of minus t and dt. Now do one thing, write this function in this form. Okay, write this function in this form. This part over here you can write. Please check. 1 second. 1 second, sir. Right here in this way, it will become, sir, 0 to a f of minus x dx. How did you get that? By writing x as t or t as x. Okay, just changing the variable, change of variable. Once we do that, please check. Now we have to write this function. This will simply become, have a look. So we'll keep this part. I think we're going to use it anyway, so we'll keep this part for ourselves. Okay, now if you look for the even function now, what did we have? We have now minus a to a fx dx will be equal to, please check, we'll have for this part, bacha, 0 to a f of minus x, excuse me, minus x, no, not minus, okay, we'll write it properly, f of minus x dx, plus we have 0 to a f of x dx, f of x dx. Okay, what we get, please check. For even function, what will happen, bacha? For even function, we'll have f of minus x as simply fx, f of minus x as simply fx. So it will become, sir, f of x only, right? So what I'm gonna get, 0 to a, same thing is there now, so fx dx with 2. This and this is same, because it's gonna become f of x, so 2 times of f of x dx. And for this part, what will happen, bacha? For this part, you're gonna get simply minus 0 to a f of x dx plus 0 to a f of x dx. Now we'll cancel each other, answer will be 0. Please check. From here I'm using this property. Okay, chaliye. So done. I've done this integration for a lot of times for you, but still very, very important. That's why I'm doing everything again. Okay, chaliye. This is the final battle, right? It has to be done once again, bacha. Now I'm not going to solve these two questions. I've solved the first two. I'm giving this to you for you to solve. Okay, I'll help you again how to solve it in both the properties. Please check over here, bacha, what we have. 0 to a f of x dx, 0 to a f of a minus x dx. What are you going to do? Take this LHS. Okay, take this LHS, and what are you going to do, bacha? Write x as a minus t. Differentiate, change the limit, you'll get the same result. Okay, this is substitution. So differentiate, change the limit, and then after doing all of that, what are you going to do at the last? Change of variable from t to x. Same way what are you going to do over here, but assume this integration of the function fx dx to be a function gx plus c. Okay, this is assumption. Assume it. Once you do that, apply this limit. What are you going to get for this side? You're going to get GA minus GB you're going to get. Correct now? GA minus GB you're going to get. Okay. Same way if you do, excuse me, you'll get here, I think it's ulta, right? It should be A to B, no? Correct? It should be A to B, bacha. It's incorrect actually. This is the mistake over here. Let me change it. Okay. This is, sir, A to B, not B to A. This should be A to B, sir. Okay, please check now. A will come here and B will come there, right? A to B. Make that change. Once you do that, have a look. So from here, what you're gonna get for this part? You're gonna get from this part you're gonna get G of B minus G of A. This is LHS, right? Correct, no? What about RHS? You're gonna get from here G of C minus G of A. You'll get over here G of B minus G of C. C and C will cancel. You'll have only what do you call G of B minus G of A left. Simple question. Please try. Please try. Okay. Let's move on now. Let us move on now, sir. What we have now, AOI. Let's solve some questions in applications as well. So we have basically, we don't have much thing over here. No MCQs, nothing. Just one 5-marker question can come. Either it can come on, I'll tell you the categories also. I've taken all the categories. Question can come on parabola and circle, means area between the parabola and the straight line, not circle actually. Circles, area enclosed by a circle can be asked. Area enclosed by a ellipse can be asked. Okay, or can be a straight line based question also be asked. Okay, they'll give you a straight line asking you area between the line and the x-axis or something like that, or y-axis, or they can give you a range -1 to 1, -2 to -4, like that they can give you. Okay, so we can solve that. Chaliye, so we have only one property over here. Just apply the limits f of b minus f of a. That's all. Okay, the f of b minus f of a. Please check. Nothing else is there over here. Let's solve the questions to get completing with this chapter as well. What we have, area under the curve, also called as application of integrals. Find the area bounded by the curve y equal to cos x. Achha, I have taken this very good question over here. This is not a PYQ. As I already told you, this session I have not taken PYQs. So I have taken normal questions. You were asking for, sir, can you take different questions? That's why I have taken some different questions. I wanted to solve that for all of you. So I have here y equal to cos x between 0 to 2 pi. Chaliye, let's draw the graph now. For cos x, bacha. We'll have starting from this place, go like this, and again going back over here, right? This point is, sir, pi by 2 is cos x, no? Y equals to cos x is the curve, the function, right? What we have on this side, excuse me, it's incorrect. 3 pi by 2, bacha. Okay, 3 pi by 2. All right, and what about this, sir? It will become 2 pi. It will become 2 pi. Agreed. So problem is these two parts are, so basically I have this part 1 and part 3 positive area, so not a problem. For this part, we have negative area. Okay, this part 2 has a negative area below x-axis, no? So negative. We have to apply modulus over here. Let's just do that. Okay, so how do you solve for, sir, part of one area? Please check. Integrate, of course, cos x from where to where, bacha? From 0 to pi by 2. Please check what you're gonna get. Cos x will become, so integration sine, no? From where to where, bacha? From 0 to pi by 2, sir. 0 to pi by 2. It becomes a sine pi by 2 minus sine 0. So basically 1 minus 0, how much is that? 1. I hope you all agree, right? Sine pi by 2, upper limit is 1, sine 0 is 0. So this is your first part's answer, 1 square units. Don't forget it's the area. Okay, chaliye. Now part 2 answer will write. For part 2 what we'll have, please check, we'll have this, sir. Again same, integral of cos x only from where to where, bacha? Pi by 2 to 3 pi by 2. Pi by 2 to 3 pi by 2. Pi by 2 to 3 pi by 2. Okay. What we have on this side, please check. It will become, sir, same thing. Sin x from where to where, bacha? 3 pi by 2 minus, pi by 2. What am I going to get? Sin of 3 pi by 2 minus sin pi by 2. We all know, bacha, this is going to be minus 1. This is going to be plus 1, right? Sin 90 is 1. Sin 270 is, where, bacha? Is negative. Sin is positive only in the first and second quadrant. Agreed, right? Okay. So sin 3 pi by 2 will be actually negative, sir. Okay. So what I get? Minus 2. Is the answer minus 2? Of course not, sir. We have to apply our beloved modulus, na, sir. Beloved modulus, na, sir. Okay. I'll get this as simply 2 square units. So such a simple question. Yes, it is a very simple question. I did not say it is a difficult question. I said it's a good question. Okay, not difficult at all. Please check part 3. What are you going to do? Integrate again. Y equal to cos x from 3 pi by 2 to 2 pi. Please check. Integrating cos x once again from 3 pi by 2 to 2 pi. Do we need to apply mod here? No need. It will be positive only. Above the x-axis, positive only. Please check. Again, we'll have sin x. Integration is sin x, sir. We have here 3 pi by 2 to 2 pi. Sin 2 pi is what, bacha? Sin 2 pi is 0. Sin 2 pi is 0. Okay. Don't write it as 1 because I said positive. Sin 2 pi is 0 minus sin of 3 pi by 2. Okay. Please check what I'm getting now. So we have 0 minus 1. I just said sin 3 pi by 2 is how much, bacha? Is nothing but minus 1, na? So we're going to get what over here? 1, again same thing, square units. 1 square units. Please check. Okay, 1 square unit here, 2 square unit. What is total area going to be? We'll have the total area to be, bacha, area of the part 1, for the part 2 and for the part 3, giving me, please check, 1 plus 2 plus 1. 1 plus 2 plus 1. So what is that? 4 square units. Please check. Done, na? 4 square units. Question is over, sir. That's simple question. Moving on now to next problem. What we have? Find the area of the parabola y square equals to 4ax bounded by its latest rectum. How do you solve it, sir? Bacha, is y equal to 4x, no? So symmetric about x-axis. Positive side. Have a look. This is your parabola. This is your parabola, right? What is they're saying latest rectum, no? Okay. This point will be, bacha, a comma 0, right? The properties, this we know, right? PO1 we have learnt. Parabola. This is point, sir. 0 comma 0. Curve will be y square equals to 4ax. We have to find what area, sir? Excuse me. Our area is this the area? No. This is this total is the required area actually. Yes, total is the required area is total thing. How do you solve it then? Please check. Make subject as x. Make subject as y, and then we have the limits, no, 0 to a. If I integrate this, let's say only this part I'm integrating. Only this part I'm integrating, okay? 0 to a. And then multiply with 2. So basically I'm saying that integrate the function y, okay, only positive part from 0 to a and multiply that with 2. What variable, sir? Of course dx, sir, because limit is for x-axis, no? Please check. Limit is for x, 0 to a. A is what? X coordinate. This is my required area. Let's put the values now. 0 to a. What is y going to be? Root 4a, and we'll have, bacha, of course, x in the root only, dx, okay? Let's do one thing. I can take the constant root 4a outside. It will become, sir, root 2. So, sorry, 2 root a. So, we'll have 2 times of 2 root a, and over here we'll have integration of root x 0 to a dx. Please check. Not difficult, na? This 2 was already there. Root 4 is nothing but 2a will be root a only, okay? Let's continue on this side. So it'll give me, okay, so we have 4 root a. What else we have, sir? Integration of x bacha is nothing but x power 3 by 2. Sorry, integration of x power 1 by 2 is there no over here. So plus 1 we will do. Please check. X power 1 by 2 is there. Root means 1 by 2 plus 1. 1 by 2 plus 1 is 3 by 2 divided by same thing na 3 by 2. Okay. From where to where bacha? 0 to a, sir. Let's take the constant out once again. We get here 4a and take here 2 by 3. This I'm taking outside, okay? It's in the denominator, no? 3 by 2 is in the denominator. It will become 2 by 3. It will become, sir, 2 by 3. 1 second. Looks messy. I'll just change it. Okay. So what we have now? 2 by 3. And over here we have, please check. So we have a power 3 by 2 minus 0. Okay, x as a, x as 0. What do we get now? 4 2s are 8 by 3 root a, and we have a power 3 by 2, 8 by 3 a power 3 by 2 plus 1 by 2 na sir. Root a means a power 1 by 2. Product means I can add the powers. It will become bacha 8 by 3, excuse me, a power 4 by 2 will be nothing but 8 by 3 a square. This is the area, right? So square units. Square unit. This is my required area, bacha. Do we need to multiply 2 once again for the lower part? No. We have already done that over here. Please check. Already taken 2. What happens now? A student will do what? After getting all of this, they'll multiply 2 to this. 16 by 3 a square, sir. Wrong answer. They'll give you option like that also if you saw MCQ. Don't do that. Already taken 2 over here, no? Please check. Done. Let's move on to now question number. Okay. Find the area of the region bounded by x square equals to 4y. Y from 2 to 4. Symmetric about y axis now. The curve is different, sir. Parabola only, but curve is different from here to here is now. Symmetric about y axis now. Again, positive side. You can see the coefficient is plus. Okay. From where to be bacha? From this point 2 to 4. This is my required area. Required area. Please check. So basically I need to integrate this to find this area A. Please check. What's my subject going to be? In this case, x dy. Y dy, sir. Limit is given for y. Please check. 2 to 4 is for y, sir. So 2 to 4. 2 to 4. Okay. If I write x, no, it will be written in the form of y only, right? How do we do that, sir? X square is given as 4y. So x will be nothing but 2 root y. 2 root y. Put it here. Do we write 2 times over here? No, sir. Only the first quadrant we are looking for. So we will not go towards left. Only the first quadrant they are given. Okay. So this A will turn out to be, please check, 2 to 4. We have 2 root y and dy. I have taken the 2 constant outside. Okay. I hope it doesn't matter. Let me just continue from here. So I get A equals to, please check, I have 2 outside. Integrating this root y, I'll get bacha y power 3 by 2 from 2 to 4. Okay. Chali. Let's solve it 2 times off. I get 4 power. Okay, excuse me. If you're integrating now, we have to divide by 3 by 2, no? I made a mistake, sir. Very big mistake. Okay. Please allow me to change that. But when I'm integrating now, it will become y power 3 by 2 divided by 3 by 2, no? So it will come outside. It will come as 2 by 2, 3. What I have now? Y power 3 by 2, 2 to 4. Okay. So I get here 4 by 3. Please check. Y means bacha will become 4 power 3 by 2 minus 2 power 3 by 2. Okay. Leaving me with, have a look, it will become, sir, 4 by 3. 4 is nothing but 2 square power 3 by 2 minus, how much is this? 2 root 2. How much is this? 2 root 2. Okay. 2 power 1 is 2 and 2 power 1 by 2 will be, what bacha? Root 2. That's why 2 root 2. What I get now? 2 and 2 is cancelled. I'm getting here. Have a look. 4 by 3, 2 ka cube minus 2 root 2. So what I get now, please check. 4 by 3, 8 minus 2 root 2. If I multiply this inside, I get here 32 minus 8 root 2 by 3 as my required area. Required area A. Please check. I can say area, right? So again we'll write square units. Square units. Please check. Done. Question is over. Simple only, not difficult at all. Chali. Now, so there's some different questions, but we still have to do these. So I'm not going to solve it. I'm going to give it to you. You have to solve from your side. You will do it, right? Please do it. I've done this type of questions a lot of times. I'll help you. Of course, I'll tell you how to do it, but you have to do from your side. You will do it, pakka? Okay. Find the area lying in the first quadrant and bounded by this. Only they're asking bacha first quadrant, okay? But circle. Please draw the circle. First part. Circle is, sir, like this. This is 0, this is 2. They're asking bacha only this area. What are you going to do? Please check. Area will be nothing but integrate this function, bacha. I'll write here the y dx from 0 to 2. How do I write, sir? X square plus y square equals to 4. So y will become 4 minus x square in the root. Integrate and find the answer. I'm not giving the answer. You have to solve it, okay? First part is done. Second part. This so is a derivation, sir. Okay? We know this very, very clearly. What is that going to be? Answer will come as pi ab, no? Okay? Again, what will happen? Your y will be nothing but in this case. Please check. Y will be nothing but, I think, b by a root of a minus x square, like, okay, y will be, okay, b by a root of a square minus x square. Okay, integrate this, sir, like this. From 0 to a you're gonna do, right? 0 to a. What about y? How can I write that, sir? This is an ellipse like this, right? So I'm asking you to write like this. This is major axis, no, 0 to a and b. Integrate this function 0 to a, okay? This subject is y, no? So y dx. This is the area and multiply this with 4 to get the required area a. Because this part into plus this part plus this plus this part, no? So you have total of 4 parts, all symmetric. That's why 4 times of this area, you're going to get the result to be pi ab. So please solve it. Please solve this. Okay, please solve this. Don't just leave it. Okay, bacha, the question can come. That's why I'm asking you to. Even though I don't have to do this question again, why I'm doing this question over and over again? Because question can come. You'll see after exams are done. When we meet after the, for the paper analysis, you'll see why I was asking to you to do all of this. So I hope this is clear. Let's move on to the next chapter now. We have differential equations. We have differential equations. What is that, sir? Order and degree, bacha. So understand one thing. There's only one, requirement over here. The differential equation has to be equation of derivative in the polynomial form only. There should not be sine of a derivative, log of a derivative, no. Derivative should be there, but only in the polynomial form. Okay, chaliye, check here, cube, only one is there, degree like this, second derivative, first derivative, okay. So we have, again, one more thing is there, bacha. We have two types of solutions of differential equation. First type is called as general solution. In that we have a variable, we have a constant involved, like plus c plus b, like that we'll have. We don't have the value for that, okay. That represents actually family of curves. But you look at, when you look at the particular solution, bacha, what will happen? It will represent a unique answer. It will represent a unique answer. They'll give you conditions for that. They'll give you x and y values for that. You use that. And then you get the values of the missing variable, like c, a, whatever it is given, and that if you put it back in the general solution, you're going to get what? Particular solution. Looks confusing, sir? Is it? I've done so many times for all of you, okay? Not confusing at all. Please check. Find the order and degree of the differential equation y double dash plus 2y dash plus sine y. Okay, sir, you said sine. I said sine of derivative. Is it of derivative, sir? No. Hence, not a problem. Okay. So degree, please check. Degree will be, sir, basically the function is given like this: d square y upon dx square plus 2 times of d by y dx, okay, plus sine y equals to 0. So my order is, sir, my order is 2 and degree is 1. Highest power of the derivative is called as order. So 2 and not highest power, highest order basically is called as the order, and highest power of the highest order will be the degree. So answer is 2, 1. Option B is correct. Option B is right. Next, moving on. But we have find the order and degree. In this case, we can't do it. Please check. Sign of the derivative. We can't find degrees, bacha. Degree is not defined. Okay. What about order, sum? Yes, order will be there. Highest power. Please check. What we have? Power 4. The order is 4. 4 comma not defined. What is that? Option C is correct. Degree not defined because of the sign of the derivative. It should be only in the terms of polynomial of the derivative. Agreed. Moving on now, what we have? Variable separation method, the simplest method to solve any differential equation. Okay, you keep the x terms on one side with the derivative of x and keep the y terms on one side with the dy. Okay, and then integrate simply. Just understand one thing, dx and dy has to be in the numerator, not in the denominator. Okay, so dx and dy has to be like this. Okay, you cannot write over here 1 by dx and integrate like this. You can't do that. That's wrong. So look for dx and dy in the numerator. I know it's very basic, but I'm still telling you, don't make this mistake. Okay, find the zero solution of the differential equation. Please check. I can apply here, bacha, very simple. Variable separation method. How come, sir? We have only one dy, rest all is x only. Okay, so let's just do that. Right here, e power x plus e power minus x dy becomes equals to, move this term on this side of the zero, of the equal to sign. I get here plus e power x minus e power minus x dx, right? Bring this term on this side. I get dy equals to e power x minus e power minus x upon e power x and plus e power minus x. I have dx, of course. Integrate now on both sides. Integrate now on both sides. What I get? What did I get, sir? Please check. I get this side as, actually before I move on to this part, let's just have a look. If I take e power x plus e power minus y, so e power minus x as t. E power x plus e power minus x as t. What will happen? Differentiate this. E power x, differentiate this, bacha. Same thing, e power minus x minus 1 will be dt by dx. dt by dx, correct now? E power minus x will remain e power minus x, but chain rule will apply for minus x. You can get that for minus x as minus 1. So simplify this. You're going to get this as e power x minus, this minus will come over here, no? Minus e power minus x with, of course, dx will become simply dt. Okay, so I can transform this like this. dy equals to integration of, please check, this will be, complete thing will be dt. So right here, dt upon t. How much is that? Y equals to ln t plus c. Y equals to ln of log t, right? How much is that? E power x plus e power minus x plus c. Final answer. That easy, sir? Yes, that easy. That easy. Done. Moving on now. Chaliye. What we have so far, have a look. Homogeneous differential equation, bacha, whenever we have equation of this form, now what you do, simply write y equal to vx. Y equal to vx, sir. Find the derivative and substitute these values in the given function. Okay, given function. Again this LDE, let's solve questions on LDE also. We have two type of form over here as well. I'll show you both the forms. Second form is like this. Please remember this. dx by dy will be there. In this case we have independent variable as x. In this case we have independent variable as y. Plus you'll have p in terms of y times of x equals to q of y. Q of y, bacha. Okay, what are you gonna get? Find the p and q, identify p and q. From there, find the if, find the integrating factor. This part, please check. E power integration of px. Px dx actually will be your integrating factor. Don't worry, we'll see from the question point of view. Not a problem, sir. To solve a question on this, we'll get it very easily. What is there? We have, sir, x dy by dx plus 2y equals to x square log x. X square log x. Have a look. So we'll take this on the side. Remember this has to be free from any coefficient. Nothing should be there. Only dy by dx should be there. So it'll become dy by dx plus 2y by x equals to x square log x by x. So what I get, please check. My standard form of LD will come now. Plus 2 by x y equals to x log x. Now check the value of p and q from here. Your p is nothing but 2 by x and q is nothing but x log x. We have to find, next step is to find the integrating factor. This is your standard form of LDE where the independent variable is x. LDE form with the independent variable x. Okay, chaliye, let's find IF now. So we'll have bacha IF as, please check, we'll have IFFs, integration of e power 2 by x, okay, e power integration of 2 by x dx will be there. Take here 2 common, 1 by x dx. What I get for this? So your IF will turn out to be, have a look, e power 2 ln x, take 2 over here, you get e power ln x the square. What is that? En ln, en l, en log, en ln. What is that? Inverse functions. What is my answer? Simply x square is my integrating factor, sir. Integrating factor, sir. After you get this, write the final answer. Y times of IF equals to integration of q times of IF, and we'll have dx, of course. So y times of x square equals to integration of, what is q, sir? X log x, no? Q is x log x, sir. X log x. What is IF, sir? One more time, x square with dx. So what I'm getting over here, please check, integration of x cube log x dx. We have to integrate this part using by parts. Have a look. Integration of x cube log x dx. Eyelet we're going to use, no? Log, then algebra comes. This is your function number 1 and function number 2. What is the integration going to be? Function 1 kept as it is, so log x is kept as it is. Integrate second one, it will become x power 4 by 4. Correct now? First function kept as it is, second function integration x power 4 by 4. Minus sign will come. Integrate once again. Differentiate the first function. First function derivative will become 1 by x. Second function integration, same thing will come, x power 4 by 4. We'll have one more integration, that's why dx will come. X and this will be cancelled with 3. I get here, please check, x power 4 by 4 log of x, first term, minus sign is there. Integration of, I can take 4 outside, x cube dx. What I'm getting, please check, x power 4 by 4 log x minus 1 by 4 x power 4 upon 4, of course plus c is there. Correct. Now integrating x cube, x power 4 upon 4. My answer is nothing but x power 4 by 4 log x. Can I take this common? Yeah. So log x minus 1 by 4 plus c. I have taken x power 4 by 4 common from here and here. Log x minus 1 by 4. My final answer, bacha, for this LDE will be this, no? I want to use this now, please check. It will become, so y x square equals to this part, x power 4 by 4. We have a log of x minus 1 by 4 plus c. The final answer, bacha, for LDE, the given linear differential equation. From here, please check from this part. I hope this is clear. This is well. Okay, moving on now. So we have completed our calculus part. Entirely calculus is over. Now we're going to complete, bacha, our matrix determinant. Okay, let's solve this. Let's go through everything that we have. We have some definitions you have to go through. What is the row matrix? Okay, what is the column matrix? What is the square matrix? Okay, so we have only one row in that. Okay, we have only one row in that. We have only one column in that. Okay, square matrix, bacha, we have where we have both rows and column equal. Okay, diagonal matrix, bacha, where we have diagonals. Okay, all non-diagonal element is 0, means only diagonals is given as some constant number, for example like this 2 2 0 0. So all the non-diagonal element has to be 0. That is called as diagonal matrix. We have scalar matrix, bacha, when they are same, like this. I wrote here, this is the form of scalar matrix also, diagonal also. Okay, antimatrix, bacha, when this is going to be 1, when this becomes 1 0 0 1. 0, sir, means all element has to be 0, 0 matrix. Okay, simply transpose of a matrix. What happens in transpose, sir? The rows becomes column and column becomes rows. Or other way to do it is simply take diagonal as it is and take the mirror image of the upper triangular matrix to the lower triangular matrix. Means take the mirror image of upper triangle to the lower triangle. That's all. Okay, that's transpose. Okay, so Aij becomes Aji, Aij becomes Aji. Okay, so A12 will be A21, A31 will be A13, like that. Okay. Symmetric matrix, bacha, when we have transpose equal to itself, it's called symmetric. When we have transpose equal to minus of itself, I'll repeat myself. When transpose is same as itself, it's called as symmetric. When transpose is equal to negative of itself, it's called as skew symmetric. Please check. Some important definitions I've already mentioned. Please go through it. Okay. Addition and subtraction. A plus B is given as Aij plus Bij. You just add the elements in the respective, place. Basically, if I'm adding, let's say, two matrices like this, so I'm going to add this to this element. One more thing. When I'm adding, subtracting, the order has to be same. Not a row and column should be equal, nothing like that. Means not like we do in the multiplication. No, number of column in the first row matrix has to be equal to number of row in the second matrix. Nothing like that. In the case of addition, subtraction, we have to take same order, exact same order. Okay, please check. So it has to be of same order, sir. Please check, same order, sir. Okay, very, very important. The statement is extremely important. Okay, scalar multiplication, that is very simple. K is a number, scalar number, multiplied to the element ij. Okay, matrix multiplication, now this is very, very important. Okay, you have to multiply. First of all, you can multiply any, so you have to take like this. If the matrix defined like this, no, so we're going to multiply. First thing is if I'm writing here, let's say m cross n, writing here p cross q, then first of all n should be equal to bacha p, n should be equal to p. This is the case. Okay, this, without this we cannot do multiplication of matrices. Okay, we have to have n equals to p. First thing is that. Apart from that, you take first row and first column respective elements. So first element with this, second element with this, like that you take, and then you add all of it. You get the first element of the resulting matrix. Yes, first row, first column will give me only one element of the resulting matrix. Same way, first row, second column will give you second element. First row, third column will give you third element, and so on. Okay, chaliye. Properties. We have the associative property also true over here. We have distributive property also true over here in the case of matrix multiplication. Okay, you can also multiply scalar either to the matrix or multiply scalar to the product of the matrix. Doesn't matter. Okay, doesn't matter. Okay, so either scalar to the matrix and then multiply the other matrix, or scalar to the product of two matrix. Scalar to the product of two matrix. Doesn't matter. Okay, one more thing. It's not commutative, sir. Very, very important. It's not commutative until unless it is actually inverse of each other. If it is inverse, means yes, commutative. Otherwise, it is not. What I'm trying to say is, if I have, let's say, b equals to inverse of a, then I can write this is okay. Then this will be okay. Otherwise, not okay. Only in the case of inverse, I can write this equal to. Otherwise, not equal to. AB will not be equal to BA. So please check. Transpose property is also listed over here. A transpose is nothing but A. Again, if I'm applying bacha transpose on the sum, I can write individually as well. Product, if I'm doing, I have to reverse it. Means AB transpose is nothing but AB transpose is nothing but B transpose A transpose. I've done questions on this. Yes. KA transpose, KA transpose. I can take K outside, A transpose. Let's move on now. So first question in the matrix bacha, what we have, they have given us 3 cross 3 matrix as the sum of symmetric and skew symmetric matrix we have to express. Okay, let's do one thing. They've given the matrix to be B. We'll find first thing as B transpose. How do you find it, sir? Make the diagonal as it is. So keep the diagonal as it is. So we have 2, 3 and minus 3. We'll keep this one as it is, no change whatsoever. What next, sir? Switch the elements from here to here. This one goes here, this one goes there. So I get here minus 2, minus 1. Same goes with minus 4 and 1. Minus 4 comes here and 1 goes here. Same I go with 4 and minus 2. 4 comes here and minus 2 over here. We have the B transpose now. So we are looking for symmetric and skew symmetric part. So we know this is symmetric, right? We have learned this B plus B dash is symmetric. Just find this quickly. So if you do that, what are you going to get? Add them. 2 plus 2 is 4. Minus 2 plus minus 1 bacha will become minus 3. We'll have minus 4, 1 will be minus 3 again. Okay. Minus 1, minus 2 will be again minus 3. We have this as 3 plus 3, which is 6. Okay. What else we have, sir? 4 and minus 2 will be simply minus 2. Please check. Simply minus 2, right? No, plus 2. 4 and minus 2 will be plus 2. 1 minus 4 will be minus 3 again. We get here minus 2 plus 4 is 2 again, and I get minus 3. Minus 3 is nothing but minus 6. This is your A, B plus B dash. Again, we have to find, this is your symmetric bacha. This is your symmetric part. Symmetric part. How come, sir? Please check here. Aij equals to Aji. Aij equals to Aji. Next, what we're going to do? Find the skew symmetric part. Please check. So for that, we're going to do what? B minus B transpose. Subtract it, sir. You will have diagonals as 0. What is that? 2 minus 2. So 0. We have this as 3 minus 3. again 0. We have this as minus 3, again 0. Please check. Minus 3 minus of minus 3 becomes plus 3, no? So 0. What else we have? Minus 2, minus 1. Okay, it'll be bacha what? Minus 1. And minus 4 minus 1 will be minus 5. Okay, we have minus 1 plus 2 will become 1. We'll have 4 plus 2 will become 6. Please check. 4 minus of minus 2 becomes plus 2. So 6. 1 minus 4 will be plus 5 actually. Okay, we have minus 2 minus of 4 becomes minus 6. Now if you check carefully what I'm getting, diagonal is 0, and what I'm getting bacha, I'm getting this as Aij is nothing but negative of Aji. Aji. So skew symmetric. What is this, sir? Skew symmetric, sir. Skew symmetric. Please check. Skew symmetric. Okay. Now how do you express this in terms of the matrix B in terms of this? Simply write this: B equals to half of B plus B dash plus half of B minus B dash. Let's just find that and verify. Half of this will be how much, sir? Half of this. So we can do this part. We'll get here 2 minus 3 by 2 minus 3 by 2. 2 minus 3 by 2. And we'll have another minus 3 by 2. Over here we have minus 3 by 2 and 3. Minus 3 by 2 and 3. We have over here as 1. And minus 3 by 2. We have here 1 and 3. 1 and minus 3 actually. So this is your first matrix. Second one, bacha, I'll write this part over here. Please check. Look out. So for this you'll have half of this. So what are you going to get the matrix to be? Please check. We'll have 0, minus 1 by 2. We have here minus 5 by 2. For this part we'll be again having 1 by 2, 0 once again. 6 by 2 is 3, 5 by 2. This is minus 6 by 2, which is minus 3, and this is 0 again. If you add them, 0 plus 2, how much is that? Add these two. How much is that? Please check. 0 plus 2 is 2, sir. Minus 3 by 2 plus minus 1 by 2. Add them. Minus 4 by 2, so how much is that, sir? Minus 2 again. Minus 3 by 2 and minus 5 by 2. How much is that? Minus 8 by 2. So minus 4 we have. Minus 3 by 2, 1 by 2. That is going to be minus 2 by 2. So we'll having minus 1. 3 plus 0 will be 3. 1 plus 3 will be 4. And minus 3 by 2 plus 5 by 2 will be 2 by 2. So again, what? 1. 1 minus 3 will be minus 2. We get here minus 3 plus 0 is minus 3. Please cross check. 2 minus 2 minus 4. 2 minus 2 minus 4. Minus 1 3 4. Minus 1 3 4. And 1 minus 2 minus 3. Done. We have proved it right. This is the way to express, sir. This is the way to express, sir. Please check. This is your answer. Have a look. Just verified this part over here. This is clear. Moving on now. Question number second for the matrix. We have A is given 3 cross 3, B is given 3 cross 3, and C is given 3 cross 3. Why the order is important? Because we can't add without the same order. Okay. So we have to add, subtract. We can do that, no? Please solve this question from your side. Find A plus B, B minus C, and verify this part. Okay. Solve from your side, bacha. I'll show you A plus B just in case if you want. Add this respective matrix elements 1 to 3, 4, 2 to minus 1, 1, minus 3 to 2, minus 1 actually. I get 5 plus 4 is 9, 0 plus 2 is 2, 2 plus 5 is 7, minus 1 plus 2 is 3, minus 1 plus 0 is minus 1, and 1 plus 3 is 4. Same way you can find sir B minus C also. Do it. Find B minus C as well and solve this question. Please solve this. I'm not solving this question for you. Very simple. Solve it. Okay. Chaliye. Done. Move on to the next question now. We have to find this question. So A is from as 5A plus 6I. We have to find this value given that A is given like this. So only problem is finding A square. So finding A square. How can you solve that? Please check. Multiply A into A, no? Multiply A into A. So if you do that, what are you going to get? Think about it. I can show you this over here. 201, 213, 1 minus 1, 0. Please check. 201 and 213, 1 minus 1, 0. Check it over here. 2 into 2 bacha is 4, 0 into 2 is 0, and 1 into 1 is 1. So 4 plus 1 is 5. First row with the second column. First row with the second column. 2 into 0 is 0, 0 into 1 is 0, 1 into minus 1 is minus 1. Next sir, 2 into 1 is 2, 0 into 3 is 0, 1 into 0 is 0, only 2. Same way you can find bacha for second row, all the columns to get the second row over here. Third row, all the columns to get the third row over here. That's your a square. Okay. Once you get that, use this equation. What they're asking: a square minus 5a plus 6i we are looking to find, right? A square we already have. You can do it, no? Can you multiply a into a? I have shown you how to do it. Okay. 5 minus 1, 2, 9 minus 2, 5, 0 minus 1 and minus 2 I have for a square. Now 5a bacha, simply multiply 5 to all elements. 5 into 2 will be 10, 0, 5, 10, 5, 15, 5 minus 5 and 0. This is 5a. This is 5a plus 6i. Right here, 6, 6, 6. Rest all is 0. Rest all is 0. They're asking us this value. Can you find it? Subtract this and add that. Please check. 5 minus 10 is minus 5 plus 6 is 1. 5 minus 10 is minus 5 plus 6 is 1. Okay. What I get now? Minus 1 plus 0 is simply minus 1. Sorry, minus 1 minus 0 plus 0 is simply minus 1. 2 minus 5 is minus 3. 2 minus 5 is minus 3, then 0. We get minus 3 over here. 9 minus 10 is minus 1 plus 0. Minus 2 and minus 5 is minus 7 plus 6 is again minus 1. Have a look. Minus 2 minus 5 is minus 7 plus 6 is going to be minus 1. 5 minus 15 is minus 10 plus 0. Okay, the last one. The last one, please check. 1 second. The last one, sir. Okay, we have 0 minus 5 is minus 5 plus 0 is going to be again minus 5 only. Minus 1 plus 5. Minus of minus, no? So plus 5. So will be plus 4, 0 there. So simply plus 4 over here. Minus 2, minus 0. So simply minus 2 only. Okay, plus 6. So plus 4. So answer is going to be this. Please check. This is your final answer. Done. Simple question. Moving on. I hope this is visible. Sir, next we have determinants. Sir, why so less questions? But I have done a lot of questions in matrices. Please go ahead, check the sessions in your 1 marker, 2 marker, 3 marker, 5 marker. Okay, even in the model papers I've done so a lot of questions. But I have taken some questions over here so that, you know, for example, questions on inverse I'll take in case of determinant. Questions on finding, what do you call, the A transpose B transpose multiplication, that also is very important. This question is very, very important. Please check. They'll give you A and B. They'll ask you A, B transpose is nothing but B transpose A transpose. Okay, I've done this kind of question. Then this one, bacha, AB inverse is B inverse A inverse. I've done these proofs. Okay, these are questions. Please solve these questions. If you want, I ask you to solve these questions. I've done these questions anyway, but if you still want to solve it, sir. Okay, if you watch my all of the sessions, you'll know that I've done these questions. Okay, let's move on now. Chaliye. So determinant, what we have for 2 cross 2 matrix, A is given like this. How do you find determinant, sir? A into D minus B into C, right? A into D minus B into C. No problem there. So this is very, very easy. For 3 cross 3, so what are we going to do? You can expand across any row, any column. Find across one row or this column, anything is okay. But I'll tell you what, wherever you find a lot of zeros, no, you find across that, it'll be easier. Okay, just look for the signs, very, very important. So whenever the position is giving you, how do you write position, bacha? Aij. How do you write any element's position? With the help of Aij. Whenever you find I plus j is odd, okay, I plus j is odd, you have to take what? A minus sign for that. Take a minus sign for that. For example, what is this term called as? It's called as A12. It's called as A12. Okay, it means what is 1 plus 2? Negative. Also negative. That's why you can see here B is taken as negative, sir. B is taken as negative, sir. Over here we have positive because it is A13, no? C is, sir, A13. C is A13. 1 plus 3 is 4. 1 plus 3 is 4. That's why taken as positive, sir. Okay. Chaliye, this part is clear. Now what are you going to do? How do you find determinant? First matrix, bacha, and first element, and then this one as the minor. Please check here. Second element, bacha, sorry, cofactor, not minor. Okay. For this element, bacha, what do we do? For B, again the sign, there's the minus sign, then cofactor. Okay. This is cofactor only, no? This is capital B actually. Capital B. Okay. Like that, we go with this cofactor of the element C. Cofactor of the element C. Chaliye. Let's move on now. Let us move on now. Alright, sir. Chaliye. So what we have then, yes, this is the formula. What is this part called? Please remember this. Okay, 1 second. This part together with this part. Okay, means with the minus sign. This part I'm saying, not the summation, without the summation, of course. This mij, if I can write it over here, no? I can write it over here. Minus 1 power I plus j mij is called as, sir, aij. It's called as aij. What is this called as? Cofactor, sir. This is cofactor, this is minor. Cofactor is nothing but, you have to take the sign also into the consideration. Minor without the sign consideration. Okay. So aij is nothing but mij times of minus 1 power I plus j. Okay. Where mij is the minor and the aij, the capital aij is the cofactor. Moving on now. What we have, please check. Determinant of transpose, bacha, we write simply like this. Determinant of A transpose is simply same as A transpose determinant. Okay, sorry, determinant of A, same thing. Okay, we have determinant of A nothing but determinant of A times of determinant of B for AB. Okay, for additive matrix what we have, simply 1. Okay, chaliye again, please check. This is also very, very important. These two are important. 2 rows and columns are identical. Determinant of A is 0, and if row or column is multiple of another, it will be again coming as 0. Please check. Okay, this is important. Now for a system of, this is to find inverse, sir. Okay, find inverse. When you are looking for finding inverse, no, if the question is given like this, Ax equals to B, you have solved a lot of questions like this. Okay, how do you find the variable matrix X taking inverse on the B side? So A inverse B. Now how do you find inverse, bacha? Simply where is it? Adjoint A by determinant of A. Adjoint A by determinant of A. Okay, don't worry, I'll solve a question like this. Adjoint A by determinant of A. How do you find adjoint, sir? I've told you A. How do you find adjoint, sir? Have they? Yeah, this is the adjoint. Okay, please check. Sorry, adjoint you find with the help of cofactors. Find the help of cofactor matrix and then take the transpose of that. Find the cofactor matrix and take the transpose of that, sir. Okay, looks confusing. Is it confusing actually? No, sir. We've done a lot of questions on this. No, so not a confusion at all. Not a confusion at all, sir. Okay, A is 1 2 4 2, then determinant of 2A. But this is answer simple, no? Order is 2 over here. Excuse me. Order is 2 over here, no? So 2 square, right? It will become 4 only, no? Option C is correct. Property. Correct, right? It will become, sir, 2 square determinant of A. So 4A. Please check. What else is there? In a matrix equation, Ax equals to B, determinant of A is 0. So singular matrix. Singular matrix, no? It means determinant of A is coming as 0. Hence, we can have either infinite or many solutions. Okay? Okay, many or of course no solutions. Many or no solutions. Okay, because for unique solution, what is there? It should be non-singular. For this equal to 0, we have unique solution. We have unique solution. Whenever this is true, for non-singular matrix, we have unique solution of the given of the variables that you've given to you in the linear equations. Please check. Okay, done. Find the inverse of the matrix 2 minus 2 4 3. Very simple question. Let's do it. What we have, sir? 2 minus 2 4 3. First find the determinant to check whether it is non-singular or not. Find the determinant. 2 into 3 is 6, sir, and 4 into 2 is minus 8. Subtraction will make it positive anyway. So 6 plus 8, right? Please check. 6 and 4 into 2 is 8, no? Yeah. Alright. So 14, sir. This is your determinant of A is 14, which is not equal to 0. So I can find the inverse. Okay. Now what is going to be A inverse? Simply we have adjoint of A by determinant of A. How do you find adjoint, sir? Chaliye, this is very, very simple. Have a look. How do you find this, sir? This will be, please check. Just interchange 2 and 3. So this 3 and 2 will be interchanged. Okay. And for this other one, just change the sign. 2 and minus 4. This is your adjoint of the matrix. Adjoint of the matrix. Let's call this to be A only. Okay, this is the matrix A, right? So what I do, across this what we do, bacha, remember this, across this we interchange. Interchange. And across this what we do, sir? Sign change. Across this we do sign change. If you want, what you can do, no, simply use your same approach. For this minor is this, positive, then 3 only. For this minor is this but negative, so minus 4. That's why minus 4 I've kept over here. Okay, then because you have to take transpose, no, that's why, right? So this is your joint. So your answer will become for A inverse. You can apply a regular approach. Okay, first find the minor, then find the cofactor, then find the adjoint, put it in the matrix, and then take transpose to find the adjoint of A. Okay, chaliye. So you'll get this as the same matrix. 1 by 14 will come over here, and you have 3, 2, minus 4 and 2. This is your answer. This is your answer, sir. 3, 4, 3, 2 and minus 4 and 2. Have a look. Done. Next, what we have? 3, 1, minus 1, 2, so that A square minus 5A plus 7I equal to 0, and find A inverse. Okay. Again, what are you going to do? Find A square first. It will become A into A. How do you solve it, sir? Simple. 3, 1, minus 1, 2. 3, 1, excuse me, minus 1, 2. Okay, can be asked in 4 marks. Okay, this question can be asked in 4 marks. Okay, 3, 1, minus 1, 2 and 3, 1, minus 1, 2. Please solve it. You get here 3 into 3 is 9, and you get 1 into minus 1 is minus 1. First element. 3 into 1 is 3, 1 into 2 is plus 2. Second element. Minus 1 into 3 is minus 3, and 2 into minus 1 is minus 2. Okay, minus 3 and minus 2. 1 into minus 1 is minus 1. 2 into 2 is 4. I get here 8, 5, minus 5 and 3. 8, 5 and minus 5 and 3. This is A square, right? What are you looking for? A square minus 5A plus 7I. Let's do that. A square minus 5A plus 7I. What we have? So we have here 8, 5, minus 5, 3. A square minus 5A, bacha, if you do 5 times of this, 15, 5 and minus 5 and 10. We have plus 7I, right? So do this. 7, 7, 0, 0. 7, 7, 0, 0. Now find this sum. How much you're going to get? If you do this, please check. 8 minus 15 is minus 7 plus 7. 0 here. 8 minus 15 is minus 7. Here we have plus 7. So 0 over here. This is clear. What else? 5 minus 5 is 0. Plus 0 will be no change. So 0 only. Minus 5 minus of minus 5. So plus 5 will be 0. Plus 0 will be 0 itself. 3 minus 10 is minus 7. Plus 7 will make again 0. Hence proved, sir. Hence proved, sir. We have proved this is equal to 0 actually. This is equals to 0 matrix of 2 order. 0 matrix of 2 order. Not oxygen. It's 2 cross 2 actually. 0 matrix of 2 order. Okay. Chaliye. Now what we have? What we have, sir? Find A inverse. No. For that, what are you gonna do? Please take this. A square minus 5A plus 7I equals to 0. Okay. And keep this 7I over here only. Taking 5A over here minus A square. Apply inverse on both sides. So A inverse in times of I equals to 5A inverse A minus A inverse A square. What I get? 7A inverse equals to 5I minus A. What I get now? So 7A inverse equals to 5 times of I, no? So 5, 0 and excuse me 5I, right? So 0, 5, not 5, 0. 5, 0 and 0, 5. 1 second. 5, 0 and 0, 5 is my 5I minus A. Bacha, what is A now? 3, 1, minus 1 and 2. Have a look. So I'm getting this as 7A inverse is nothing but, have a look. I'm getting this as 5 minus 3 is 2. 0 minus 1 is minus 1. And 0 minus 1 is going to be plus 1. 5 minus 2 is again 3. Okay, please check. Okay, 5 minus 3 is 2. 0 minus 1 is minus 1. 0 minus 1 is plus 1. 5 minus 2 is again 3. Okay, so my value for A inverse will be nothing but 2 minus 1, 1, 3 with what, bacha? With 1 by 7 over here. Okay, so this question is from matrix actually, but since I've taken it over here, it's alright. Okay, both chapters are very similar, no? That's why I've taken it over here. Okay, questions from matrix actually. Okay, please check. 4 marker. Done. Move on now. Now this beautiful question, sir, to find inverse. Okay, they've given A, we are finding inverse. First step was to find bacha determinant of A. Okay, from there what we got, please check. From there what we got determinant of A as minus 1, which is not equal to 0 means, we can find the inverse. Okay, so this is the equation Ax B. Please check here. Same, no? 2 minus 3 plus 5. Okay, we have 3, 2 and minus 4, 1, 1 and minus 2, 1, 1 and minus 2. Same equation I've taken here. This is A, This is taken as A. X is the variable equation that we have to find out, variable matrix that we have to find out. This is your B, the constant matrix, which is minus 11, minus 5 and minus 3. 11 minus 5 and minus 3. Okay. Chaliye, once we have that, we applied this rule. First write all this element bacha in one row. Please check. Minus 2, 3 and 5. Minus 2, 3 and 5 over here. 3, 2, minus 4. So 3, 2, minus 4 and 1, 1, minus 2. Okay. This is 1, sir. There's a 1 over here. So 1, 1. Minus 2. Okay. After this, what you're going to do, please check. Write the first two row again. So 2 minus 3 and 5, 2 minus 3 and 5, and 3, 2 and minus 4 again. Okay. 3, 2 and minus 4. This is minus 4, bacha. This is minus 4. 3, 2 and minus 4, right? Again, correct. Okay. Now what you're going to do, please check. After this, cancel the first row and first column. 2 into minus 2 is minus 4, and plus 4 will be 0 for adjoint. Okay. Next will be 5 into 1. Plus 6, so minus 6, so will be minus 1. Last will be, sir, 12 minus 10. 4 into 3 is 12, no? So plus 12 minus 10 will be again 2 only. Please check. 4 into 3, sir, is 12. The minus will make it positive only, right? Minus 10 will become 2 only. Same way if you do, you find the adjoint. You find this adjoint. Once you get the adjoint, find bacha A inverse by changing the sign. This is the word bacha. What is the A inverse formula? A inverse is, sir, adjoint of A by determinant of A. This is your adjoint, right? Determinant is minus 1. So divide everything by minus sign. It will change the sign. So 0 will be 0. Minus 1 will become plus 1. 2 will become minus 2. 2 will become minus 2. Minus 9 will become plus 9. Minus 23. Minus 1. Plus 5. And minus 13. This is your A inverse. This is your A inverse. Please check. Once we have this, we can find X using this formula. A inverse times of B. A inverse times of B. Please check. A inverse times of B, sir. Alright. We can find that. From there, what we get? Please check. Multiplication is there. 0 into 11 is 0. 1 into minus 5 is minus 5. Minus 2 into 3 is minus 3 is plus 6. So we get here plus 1. Minus 5 plus 6 is plus 1. Next, minus 2 into minus 11 is minus 22. 9 into minus 5 is minus 45. 23 into 3 is minus 69. What we get? Plus 2 and plus 3 like this. So X is going to be 1. Y is 2. Y is 2. And Z is minus. Z is 3 actually. Z is 3. Please have a look. Okay. Simple question. Very, very simple. Moving on now. Vector algebra. Yes, sir. We have completed the matrix of determinant as well. Okay. So, sir, I know it's not going to be full chapter that we're doing, that the way we do in the normal classes. It's a marathon, right? So, we have to quickly solve and learn the concepts and move on. Revise the concept, revise the formula, and move on to the questions. Okay. That's what we're going to do. So, same thing we'll do for the vector algebra also. Please check. Basic definitions. Let's start out in the vector in the 3D form. X, Y, Z. So X is the X component, of course, I cap, and Y J cap represent the Y component, and K cap represent the Z component. Okay. So we have position vector of the point PXY given like this. Okay. And zero vector will be given by like this picture: 0 I cap, 0 J cap, and 0 K cap. Okay. This is very important. This is very, very useful in the questions. Unit vector formula: A cap is nothing but A vector by A cap is nothing but vector A by mod of vector A, sir. Okay. Same thing we use in the case of projection across A. Let's say I'm using this projection of vector B on A. Vector A. What are you going to do? B dot with A cap only. We're going to do B dot with A cap. It will become, sir, B dot vector A upon mod of vector A. Please check. Okay. Now we have magnitude of the vector given like this. You take square root of squares of all the components x, y, and z. So a1 square, a2 square, and a3 square. What we have now? For some bacha, you just have to add the identical components. So x to x, y to y, z to z. Okay. So we are adding a1 to b1, a2 to b2, a3 to b3. So because a1, b1 are the I component or the x component, a2, b2 is the y component, and a3, b3 is the z component. Okay. Chaliye. Difference bacha, same thing we do. We know that the difference is also same as sum only, but just positive and negative terms will be there. So a1 minus b1, a2 minus b2, and a3 minus b3. Done, sir. What else? Scalar dot product. This is very simple. Okay, this is very, very simple. No, what do you do here? A dot b. You write it as a dot b. What are you gonna get? A b cos theta. What do you get? A b cos theta. Okay. I can write this as a1 into b1 plus a2 into b2 plus a3 into b3. Okay. Please check. And this is very, very important. When they are perpendicular, you get a dot b as 0. How come, sir? Please check. So you'll have cos theta equals to 0 when theta is 90 degrees. When theta is 90 degrees. Now, first question. In vector addition, which of the following is not true? In the vector addition, which of the following is not true? Let's have a look. So I'll take a vector bacha, AB. There is vector BC also, so we'll take here from B to C. So BC, and there's AC as well. Okay, so let's take this. So you know, if the vector is AB and BC like this, what is the sum vector bacha? This only, no? This is the resulting vector R. We write this R vector as nothing but AB plus BC, or simply write this as vector AC is nothing but AB plus BC. They're writing on the same side, no? So we can write this on the side, it will become 0 equals to AB plus BC minus AC. Okay, now look for the very important not true. We have to look for incorrect option. So we have to look for incorrect option, not the correct one. We have to look for incorrect option. Please check which is right, which is wrong actually, not right. So AB plus BC minus AC. Okay, AB plus BC minus AC, this is right, no? Okay, this also is right, sir. I can write AC as plus CA, right? Reverse the direction, it will become plus CA, no? This is also right, but we can't write this as minus CA. This is incorrect option. Option C is incorrect. We can't write this, because if you write this again, no, it will become 0 equals to AB plus BC, and this AC will become, sir, minus. So minus of minus CA, which will give me AB plus BC plus CA. So they are saying minus CA. Not possible. Not possible. Option C is the incorrect option. Please check. They are asking not true. So incorrect option is option number C. Have a look. Unit vector in the direction of A plus B. A is given, B is given. Let's find this, sir. So if I take, bacha, let's say vector C as vector A plus V. What are they asking actually? They are asking us C cap will be vector C upon mod of vector C. Mod of vector C. That's what they are asking us. Please check. Okay. Chaliye. So let's find A plus B first. We will get this vector C as 2I cap plus I cap. Minus I cap will become, bacha, plus I cap. I have minus J plus J. So 0 J cap. And I have plus 2K minus K. So plus K cap. Simply my vector C is nothing but I cap plus K cap. I cap plus K cap. What I get now? Vector C mod as will become vector C by mod of vector C. Okay, this is the unit vector across the vector C. So it will become, so I plus K by root of, what is the component of I, sir? I is 1 square. So I plus K by root 2. I plus K by root 2. Option number B is correct. Option number B is correct. Please check. Done. Have a look. Alright, sir. Move on now. Vector or cross product of the vectors. How do you do it, sir? If I have vector A and B given like this, you take first column as, first row as I, J, K. Write the components A1, A2, A3 and simply find the determinant of this. Simplify the determinant across the first row. And the formula is AB sin theta. One more thing is there. In the case of dot product, we are dealing with perpendicular lines. Over here, we'll be dealing with parallel lines. Why is a parallel? When they are parallel, theta will be 0, na? Okay, or pi. Opposite direction is pi. Okay, what happens with sin theta, bacha? It will be 0 only, no? So that's why whole thing will become 0, sir. It will become whole thing as 0. I know I'm going a little faster, but please accept it, bacha. We have a lot of things to do. We are still in vector 3D. We have to go and do linear programming. We have relation functions, ITF, all of this is left. Okay, so we'll do all of that. Don't worry, we'll not skip anything. We'll do everything. Okay, just be with me. Chali. A line passing through the point A. This is there, bacha. We have been asked this derivation multiple occasions. Very, very, very important. Even in the question point of view and the derivation point of view, they also ask the lines are perpendicular, prove it perpendicular, or missing the value, you can find it out. Okay, when we take perpendicular, what we take? B1, we take two lines, no? So B1, B2, and they've not given over here. So A1, B1 if they was given, we'll see the question. I've taken the question like that, don't worry. So A1, B1 plus A2, B2 plus A3, B3 will become equal to 0. Remember, for perpendicular line, bacha, we had A1, B1 plus A2, B2 plus A3, B3 will be equal to 0, sir. Will be equal to 0. What about parallel, bacha? What about parallel, sir? Remember this, A1 by A2 will be equal to B1 by B2 will be equal to C1 by C2 will be equal to a constant K. Forgot all of this? Taught you all of this? Please check. Okay, I've done all of this bacha for all of you. The formula for any angle between two vectors. How do you find the angle between any two vectors? A dot B upon mod of A times mod of B. Okay, angle between two lines bacha. What if we're talking about angle between two lines? Let's say this is the line 1 with the vector B1, another line is there, vector B2 in the Cartesian plane, 3D plane of course. Then how are you going to solve it, sir? Simply we'll take dot product of them divide by B1 B2 modulus. How, sir? Please check. No, remember this. If I'm asking to find the dot product of which, how you write it? B1 dot B2 equals to mod of B1 mod of B2 and cos theta, right? So it will become, so please check. So cos theta will become, sir, B1 dot B2 upon mod of B1 times mod of B2. Mod of B2. Please check. Mod of B2. Have a look. Done, right? Mod of B2, sir. Okay. Doesn't look like B, sir. Very weird. Sorry. Let's move on now. The angle between two vectors A and B which magnitudes are given like this. Okay. So they are given here. Vector A ka magnitude is nothing but root 3. Vector B magnitude is nothing but, please check, 2. And A dot B is given as root 6. Okay. So cos theta is nothing but A dot B by mod of A times mod of B. What I get now? Root 3 into 2, okay, divided by what we have, my bad sir, we'll have root 6 in the numerator. They have given here as root 6, so please check. The mistakes are over here. We have this as root 6 now. It will become root 3 into root 3 in the denominator actually. Okay, so root 3 into 2, not root 2, root 3 into 2, not root 2, root 3 into 2. Okay, chaliye. So what I get, root 3 times this will be root 2. I get here root 2 by root simply 2. It will become 1 upon root 2. What I am getting, cos theta equals to 1 by root 2 means theta equals to pi by 4. Theta equals to pi by 4. Answer is option number B. Option number B. Please check. Simple question. Moving on now. For two skew symmetric intersecting and non-parallel lines, we have the formula for bacha. Distance between them is given as, please check this. We find the difference of the point, the position vector of the point which is passing through. So A2 minus A1, we find the difference of that and take cross product of B1 cross B2 and take the dot between those two with the modulus of, divide by the modulus of B1 cross B2. Difficult? We have done so many questions of this. So many questions we have done on this bacha. Not difficult at all. Okay. Even in the case series we have done this question. Very, very important. Okay. Chaliye. So that the position vector of the point P which divides the line joining. Okay, this derivation, sir. Okay. Chaliye. Derivation of section formula. I've done this, but I'll do it again anyway. Not a problem. We'll do it, sir. It's a final battle. We have to do it, sir. Chaliye. What is there for us? The points are given with the name A and B. So let's call this A. Let's call this B. Okay. And there's a point P over here which gives us the section as M2N. Section is M2N. Okay. This is the origin. This vector is called as vector A. Okay. Vector A and vector B. This is called to be vector B. Let's call this to be resulting vector R, sir. Resulting vector R, sir. Okay. What do we know, sir? We know AP to PB. We know AP to PB is M2N. Ratio is given, right? AP to PB is M2N. Please check M2N. Okay. Cross multiply now. What we get? NAP equals to MPB. Write in the vector form now. So NAP vector equals to MPB vector. MPB vector. Now what is AP vector? Please check from the triangle of addition. Vector AP, sir, is nothing but vector OP minus vector OA. OP minus vector OA. And this side M vector bacha PB. Please check for PB. For PB, sir, we have vector OB minus vector OP. OB minus OP. How come, sir? The condition is from triangle law of addition, right? Triangle law of addition. Okay, so OP will be nothing but AP plus OA, right? AP plus OA, sir. Okay, direction sense of the vectors. Okay, please check. So I get now, excuse me, I made a mistake. It's not vector n, bacha. It's not vector n, sir. It's simply n. It is simply n, sir. OP is how much, sir? OP is vector r. So right here, vector r minus OA is vector A equals to m times of vector OB is how much, sir? Vector B. OP is how much, sir? Again r. Open this bracket. I get nr minus na equals to mb minus mr. Bring the r terms on this side and this term on this side. I get bacha n times of vector r plus m times of vector r equals to mb plus na. Take vector r common from here. We get vector r equals to vector r times of m plus n equals to mb plus na. I'm getting here vector r is equals to mb plus na divided by m plus n divided by m plus n. Please check. M plus n. This is clear? Clear? Please check. Done? Okay. You have to prove this only, no? Done, sir. Okay. Now, if vector A and B and C are mutually perpendicular vectors, what it means? It means, sir, A is perpendicular to B, which means, sir, A dot B is 0. Next, which what we have? A perpendicular to C, which means, sir, A dot C is 0, and also B perpendicular to C, bacha, it means what is this, sir? Sorry, B perpendicular, no, excuse me. It means B dot C is also 0. B dot C is also 0. Okay, chali. Okay, vectors of equal magnitudes, then prove that the vector ABC is equally inclined to A, B and C. Okay, so let's do that. So first thing, vector A plus B plus C, vector A plus B plus C is inclined equally, right? So dot with, I take bacha first vector A. What's the result going to be? Please tell me. It's going to be, sir, over here. It's going to be, sir, A dot A bacha will be A square, no? Will be A square, sir. Okay. So one second. I can do better. Not A square over here. We'll write it on this side, A square part. I can write this side as, have a look, mod of vector A plus vector B plus vector C, and then mod of vector A, and we have here, sir, cos, let's say, call it as alpha, cos alpha. Okay, cos alpha is the angle between, alpha is the angle between vector A and A plus B plus C. They're saying that vector A plus B plus C is equally inclined with vector A. So, sir, A, vector B, vector C, vector is three different vectors, no? Vector A, vector B and vector C, let's say, are three different vectors, sir. But they are equally inclined to what vector? The sum of all the three. Sum of, let's say the sum is going as like this. So they are saying that angle between this and this, this and this, and this and this is same. So what is this going to be? A plus B plus C. I'm not giving you a proper figure over here, just a rough idea. The resulting vector is nothing but equally inclined to all the vectors. How come, sir? It's in 3D space, bacha. It's in 3D space, sir. If you draw the 3D space, no, it'll come better. Please check. You can draw inside, actually, that will be better. This is a vector ABC, vector ABC, okay? A plus B plus C, sum of all the three. This can be vector A, vector B and vector C. Vector A, vector B and vector C. Sum. So saying that this vector ABC is equally inclined to vector ABC, not XYZ. This is this angle and this angle is same, sir. Okay? So let's take the angle with the first vector to be alpha. We'll take the other angle to be beta and gamma, like that. Chali. It's a good question. We'll see. And there is this part, just wanted to explain you this. That's why I've taken the figure. Not required. Okay. So we get here, bacha, please check. A dot A is how much, sir? A square. What about A dot B, bacha? A dot B plus we have C dot A, right? And this will be as it is, vector A plus vector B plus vector C multiplied with vector A modulus, okay, and cos alpha. Check here very carefully. This part is 0. This part is again 0, right? What I'm getting? I'm getting here mod of vector A square is nothing but vector A plus vector B plus vector C the mod times of vector A the mod and cos alpha. This will cancel this one of the squares over here. Please check. This will cancel one of the squares over here. I want to find the angle, no? So I get cos alpha equals to, please check. This will remain on this side only. So vector A divided by, this will come over here, right? This whole thing will come over here. So mod of A plus B plus C, sir. Mod of A plus B plus C. This is for cos alpha. This is for cos alpha, sir. Have a look. This is for cos alpha. I can do for cos beta also same way. Let's do for cos beta also same way. What will happen? In this case, we're going to take dot with B. A plus B plus C. I'll take this dot with this dot vector with vector C, B in this case, vector B in this case. It will become, please check, mod of vector A plus vector B plus vector C. Excuse me, it's a mod. Looks confusing, no? This is a mod and this is not a mod, this is a bracket, okay? Chaliye. This is a bracket, okay? This is a dot product, no? And this is a mod over here. Mod with vector A and we have cos, let's say beta this time. Cos beta this time. What I'm going to get? Same thing, A dot B will be A dot B plus B dot B will become B square. We'll have then C dot B, okay? And this side I'll have the same thing. A plus B plus C with vector not A, right? This is B, no, in this case. This is B, right? This is B in this case. Sorry. This is vector B actually. And cos beta. Okay. Please check. It'll be 0. Again, it'll be 0. What I'm getting now? Same thing, bacha. I can cancel this B with this square. I'll end up with B divided by mod of A plus B plus C, right? It will become equal to cos beta. Look at cos alpha, mod of A upon A plus B plus C and mod of B upon A plus B plus C is cos beta. Same way, but I can get for third part cos gamma as mod of the vector C upon mod of A plus B plus C. Now you only tell me these angles cos alpha, cos beta and cos gamma, they are not equal? They are equal, sir. Cos alpha equals to cos beta equals to cos gamma. How come, sir? Because bacha actually mod of A equals to mod of B equals to mod of C. How come, sir? They have given here. Please check. Of equal magnitude. They have given here of equal magnitude. Of equal magnitude. Okay. It means if you compare the three fractions, this fraction, and this fraction, compare here. The denominator is same, no? The denominator is same. A plus B plus C the mod over here, and also the numerator is same. Mod A equals to mod B equals to mod C. Mod A equals to mod B equals to mod C. It means, bacha, the cos will be for all angles equals to, it means what I get? Alpha equals to beta equals to gamma. Alpha equals to beta equals to gamma. It means A plus B plus C, A plus B plus C vector is equally, have a look, inclined to vector A, vector B and vector C. That's your answer. Please check. Done. Have a look from the beginning. Done? Okay, so next question. Okay, all right. What we have over here, if vector A equals to I plus j minus k, B equals to I plus 2j minus plus k, and C equals to minus I plus 2j minus k. Find the unit vector perpendicular to both A plus B and B plus C. Let's limit one thing. I'll take vector x equals to vector A plus B. Let's find this quickly. Vector x now, A plus B. So I plus I is 2i cap, j plus 2j is plus 3j cap, and minus k plus k is simply 0k cap. minus k plus k, simply 0 k cap. What about bacha? Vector by, I'm going to take vector b by to be b plus c. Please check b plus c over here. I minus I is 0 I cap plus 2j is 4j cap, and I get plus k minus k is nothing but minus 0, sorry, plus 0 k cap. Correct now? Plus k minus k is 0. Plus k minus k is 0? Yes, sir. So I get now they're asking find the unit vector perpendicular to both. So let's look for the vector. I'll call a vector z, which is nothing but perpendicular to both bacha, to both sir, x and y, and z perpendicular to vector y also. How can you find this, sir? How can you find this, sir? Very simple. Find x cross y na. X cross y will be a vector perpendicular to both the vectors x and y. I repeat myself. X cross y is a vector perpendicular to both the vectors x and y. Okay, so let's do that. I get here I, j and k. What is bacha x going to be? 2, 3 and 0. What is going to be y? 0, 4 and 0. 0, 4 and 0. Let's find across I, j, k. I get here vector I times of, this is cancelled. 0, right? Please check. 3 into 0 is 0, 4 into 0 is 0. Gone. Minus j times of, please check. Minus j times of. I get cancel this out. 0 into 2 is 0 and 0 into 0 is again 0, so 0. Plus k times of, please check. This and this is cancelled. 4 into 2 is 8 minus 0. So my answer is going to be, please check, vector x cross y is nothing but, please check, simply plus 8k cap, plus 8k cap. What are they asking? Unit vector across this. I've taken this vector z as basically 0 I cap now and 0 j cap and plus 8k cap. What are they asking, sir? They're asking us, sir, z cap. They're asking, sir, z cap will become bacha vector z upon mod of z. What I get now? So 8k cap upon root of 8 square. How much is that? Please check. 8k cap upon 8. What I get? So z cap is nothing but, check here, 1 or simply k cap. Have a look. Question was looking difficult by looking at the statement, but actually is very simple. Extremely simple. One we need of cross product, that's all. We need one of cross product. Have a look. Done. If you have a doubt, let me know in the comment section. Okay, shall I move on now? Let's move on, sir. What I have, bacha? What I have, sir, if a, b, c are unit vectors such that a plus b plus c is 0, find the value of a dot b plus b dot c plus c dot a. This is simplest question in all the time of this chapter. Whole square bacha will become, please check, it will become, sir, mod of a square plus mod of b square plus mod of c square plus 2 times of a dot with b plus b dot with c plus c dot with a. Done. This and this is the same thing. This and this is the same thing. Okay. How much is this given as? 0. So right here 0 equals to, they are given as unit vectors, no? Means what is their magnitude, bacha? They have given a unit vector, so a will be equal to vector b will be equal to vector c will be equal to 1. It means, sir, 1 square plus 1 square plus 1 square plus, let's call this to be 2 times of lambda. I'm calling this to be, bacha, lambda. Okay, I'm calling this to be lambda. What I'm getting now, please check. 0 equals to, sir, 3 plus 2 lambda. I'm getting here lambda equals to minus 3 by 2. Minus 3 by 2. Hence, sir, I'm getting here, please check, a dot b plus b dot c plus c dot a is nothing but minus 3 by 2. Final answer. Have a look. Final answer. Okay, let's move on now. We have, sir, 3D geometry. For 2 points given as a, x1, y1, z1, b given as x2, y2, z2. This is the distance formula. Okay, chali, learnt in grade PU1 actually. This is a midpoint formula. This is your section formula. Okay, let's move on. Dash and cosines. This is very important. This is, sir, very important. Very important, bacha. Okay, So if the angle is nothing but alpha, beta, gamma for the x, y and z axis, alpha, beta, gamma is for the x and y, z axis, your direction ratio, cosine will become, sir, cos alpha, cos beta and cos gamma. This is what, sir? DC, direction cosine, sir, direction cosine, okay? And you'll have this equation satisfying this. So what we get, we call this to be L, we call this to be M, and we call this to be N. So basically, L square plus M square plus N square equals to 1. Clear now? Okay, and this is going to be dr, sir. This is going to be your dr, sir. A, B and C are your dr. What is this, sir? A, B and C is your direction ratios. Have a look. So I can represent the direction cosines with the help of direction ratios, sir. Okay. Equation of a line, bacha, in vector form. Very simple. In Cartesian form, how many times we have done it? Very, very simple, sir. What is this, bacha? This vector A is the position vector of the point where it is passing through. Vector B is, sir, which is the line L is parallel to. Okay. Line L we call it. Line L is parallel to the vector B. That's why parallel over here is what is this form called as? Collinear vector form, na? Collinear vector form. So L is parallel to B, parallel to vector B. That's why lambda B. Okay, and vector A is what? Position vector of the point where it is passing through. So A plus lambda B. This is a Cartesian form. What is ABC, sir? ABC is nothing but, like this. Vector B is nothing but AI cap, BJ cap and C K cap. So ABC is nothing but your DR, direction ratio of the vector B only. Okay, and what is x1, y1, z1? The coordinates of the point A. Coordinate of the point A, sir. In this case we are dealing with position vector. In this case we are dealing with coordinates. X1, y1, z1 is the coordinate of the point A, and ABC is the DR, the direction ratio of the line B, the line or the vector B. Chali. Angle between two lines, sir. Same approach, bacha, cos theta. Remember this, we have done this in this vector form also. This also. Please check. With the help of dr. This is with the help of dr, sir. This is with the help of dc. Please check. Done. Okay. Simple formulas are there. Remember this, very, very important. We have to use it sometimes. That's why I'm letting you know. Very important. Extremely important, sir. If you know the formulas, you get the answer directly. Vector 3D is all about formulas, sir. Concept is there, of course, but you've learned that already. Okay, vector 3D is about formulas. You cannot forget that. Okay, chaliye. Let's move on now. A line makes equal angles with coordinate axis. It means, sir, alpha equals to beta equals to gamma. It means, sir, cos alpha equals to cos beta equals to cos gamma. It means, sir, L equals to M equals to N. It means, sir, L square plus M square plus, N square bacha equals to what's a 1. I can write here this simply as 3L square equals to 1. So L square equals to 1 by 3. So L equals to plus minus 1 by root 3, which is equals to M also and N also. So answer is plus minus 1 by root 3 for all L, M and N. Answer is option number B, sir. Option number B, sir. Please have a look. Option number B. Done? Okay, let's move on now. If a line has the direction ratio 2 minus 2, 2 minus 1 and minus 2, then its direction cosines is what? Okay, they've given A, bacha. They've given A as 2, B as minus 1 and C as minus 2. C as minus 2. What are they asking? DC. So they're asking, bacha, L. L will be given by A upon root of A square plus B square plus C square. Now, how much is that? 2 upon root of 4 plus 1 plus 4, right? So 2 upon root of 9, right? How much is that? 2 upon 3. 2 upon 3. Okay. Again, bacha, we can take both plus minus, no? We can take both plus minus. Okay. What about N? This is a minus sign, no? It will become minus plus upon 1 by 3. It was plus here. That's why I wrote here plus minus. Okay, this is plus minus. Please check. There's a difference. What is this, sir? Minus plus. How come, sir? We have some minus sign over here. Okay. So when I write this, no, minus plus b upon this whole thing, it will become, so minus 1 upon plus minus 3. Okay. So this plus will make this minus and this will be plus. So I get here minus plus actually. I get here m is minus plus. Please check. very important, and will be equal to bacha, we have minus 2, no, will become minus plus 2 by 3. So point is actually, so you can write L, M, N in two different ways. What I get, first one will be, please check, I have a 2 by 3 comma minus 1 by 3 comma minus 2 by 3. That's why I said like this. If you're taking the plus sign over here, you have to take the minus sign over here. What is the coming first? Minus sign. How come, sir? Because B is negative. This is positive, this is negative, this is negative. That's why I'm saying plus minus minus. Other combination is what, bacha? Other combination is, sir, minus 2 by 3. Okay. Over here what I have? Plus 1 by 3. And over here what I have? Plus 2 by 3. So you can pick any of the combination, but in that only. We can't take this to be plus, this to be minus like that. We can't do that. Okay, we can't change it. Minus plus we can't change. Okay, we can't take minus plus minus. That's not right. Only these two are the correct options. Please check. Okay, let's move on now. Let us move on now, sir. I hope this is clear. Can we move on? Of course. This is a formula, right? For A is this, for B will be again same thing will repeat, and for C you'll have, for N you'll have C upon the same thing. C upon the same root. A square plus B square plus C square. Please check. Done? Well, let's move on now. Lines x minus a upon minus 3 equals to y minus 2 upon 2k and z minus 3 upon 2. Okay? A perpendicular, bacha. Perpendicular means, sir, we have to look for one thing. We have to look for one thing. What is that? What is that? We have to look for, sir, actually, the coefficient of x. We have to look for coefficient of x, y and z. It should be always 1. It should be always 1. Please check. Over here x is 1, y is 1, z is 1. X is 1, y is 1, z is 1. Not even minus 1. Only 1. Okay. When that happens, what will happen? You can take this directly, bacha. A1 to b minus 3. B1 to b, sir. B1 to b 2k and C1 to b from here. What do you have? 2. Same way I can take, sir, A2 to b from here 3k and B2 to be 1 and C2 to be minus 5. What they have given? They have given, sir, perpendicular. It means we know that A1 A2 plus B1 B2 plus C1 C2 has to be equal to 0. Why, sir? For perpendicular lines. Please check. What I get? 3 into minus 3, right? I get here minus 9k. What about this? 1 into what I have? 1 into 2. So I get plus 2k. Then what I have? Minus 10, no? Equal to 0. Please check. I'm getting here minus 7k equals to plus 10, giving me k value is minus 10 by 7. K value is minus 10 by 7. Option A is correct. Option number A is correct, sir. Done? Simple. Got it? Angle between two diagonals of a cube. Excellent question, sir. Let's draw the cube first. Okay. I can draw it like this. Alright. Okay, before that, I'll think it'll be easier if I draw the other way around. I'll draw the cube first, then take the coordinate plane. Okay. So I'll draw the cube first, then take the coordinate plane, bacha. It'll be easier actually, that's why. Okay. So let's draw the cube like this. Okay. This is there. Let's call this to be x. Let's call this to be y, and let's call this to be z. X, y, and z. Okay. The vertex I can call, sir. Let's call this to be A, B, C, and excuse me. I can write here C here, D here, and write this as, let's call this to P, Q, R, and S. P, Q, R, S. Okay. So what is my diagonals, bacha? My diagonals are here. Please check. Diagonals are here. First one is AQ. From this one to this one. First one is, sir, AQ, bacha. No. Yeah. First one is either AQ. Yeah, correct. This is AQ. Other one is, sir, CS. They equal actually. Please check. Diagonals are. The diagonals actually are. A cube and CS. Let's write the coordinates of AQ and CS. For Q, you'll have, bacha, X will be A, Y will be A, and Z will be 0. Because, sir, Q is a point in the plane XY. So A, and 0. for Q. What about C, bacha? C is in the point in the 3D space. So for C, you will have A, comma A, comma A. All three is A. What about S, sir? For S, you have, sir, 0, 0, 0, 0. 0, 0, 0. What about this, bacha? What about this, sir? For Z, you will have 0, 0 and A. 0, 0 and A, sir. Okay. Now let's find the vectors AQ and CS. Let's find the vector AQ first. What I'm going to get a vector AQ as? Please check. AQ will turn out to be A minus 0, which is A minus 0 I cap, excuse me, not A vector, simply A minus 0 I cap. Alright, I write this next one as A minus 0 J cap plus A minus 0 J cap plus what I have 0 minus A K cap. How much is this? So vector AQ is turning out to be, please check, A I cap plus A J cap plus, sorry, minus na, A K cap minus A K cap. Have a look. Minus A K cap. This is done. Alright. Now same way I can do, bacha, for other vector CS, right? Other diagonal CS or SC we can do. Vector SC. What will happen to this? Please check. It will become, sir, A minus 0. How much is that? A I cap. Correct na? A minus 0. This is all 0, 0, 0, right? So A minus 0 is A I cap, A J cap and A K cap. How come, sir? A minus 0 is 0. Y vector component. Y minus 0 is again, sorry, A minus 0 is again 0. And Z component is again A. So A minus 0 is also 0. What I get? SC is also known now. How do you find, bacha, angle between them? Cos theta is nothing but we have known the vectors. Okay, the what is this, sir? Direction ratio is known right here. A into A plus A into A plus A into minus A. A into minus A, है ना? A into A into A and A into minus A. Done. What about this, bacha? Root of this, sir, A square plus minus A ka square. Product with same thing over here, A square plus A square plus A square. Correct now? For this I have this square, this square in the root, and for this I have this square and this square. So A square minus A square and A square. What I get the result to be, please check. I'm getting here cos theta equals to, please check, it will become, sir, A square numerator. This also is plus A square. What is it going to be? Minus A square. What about the denominator, sir? I have 3 A squares. So I write here root 3 A squares times of root 3 same thing A squares, root 3 A squares. Have a look. Okay, so what I get now, please check. This is cancelled now. This is cancelled, right? So I get only one A square in the numerator. What is the denominator going to be, bacha? I have root 3. How much is that? 3. Root 3 into root 3, sir, 3. What I have? A square is nothing but A. In the root, it also is A, sir. So I get A square again. Cancel this. I'm getting this as 1 by 3. Please check. I'll tell you again. This is root A square, no? Come out as A. This is root A square, no? Come out as A. So A into A is nothing but A square. So what I'm getting now, please check. I'm getting this. Cos theta is 1 by 3. So theta is nothing but cos inverse of 1 by 3. Please check. Cos inverse of 1 by 3. Option is option number A, sir. Option number A. Correct now? Root 3 to root 3 is 3, sir. And A into A is nothing but A square. A square cancels. I get 1 by 3 as cos theta. This is a formula, right? I told you this formula right now. This formula, bacha. This formula, sir. Cos theta in terms of direction ratios. Have a look. Same formula I've been using over here. Right? Simple? Not simple? Little bit thinking. Yeah, I understand that. Good question. It's a very good question. Okay. Chaliye. The shortest distance between the lines L1 and L2 whose vectors equation are given like this. Okay. So I'll not tell you how to, I'll not give you the answer for this question. I've taught you so many times. I'll tell you how to do it. You have to do from your side and give me the answer. You have to draw, solve and comment answer for D equals to how much? What are you getting, sir? D equals to how much? Also, I'll tell you how to do it. The formula is there. D equals to, sir, A2 minus A1 dot with B1 cross B2 divided by mod of B1 cross B2. Okay, chaliye 1 second. Okay, done. Chaliye, so how do you find say A2 minus A1? So I'll tell you A2 also. Vector A2 is over here, please check. 2i plus j minus k. This is a vector A2. What is vector A1, bacha? Vector A1 is over here, please check. I plus j, only I plus j. So what are you going to get for A2 minus A1? Please check. It will turn out to be 2i minus I is simply I. It will be simply j minus j is going to be 0 and minus k will be nothing but minus k. Correct, na? J minus j is 0 and minus k into nothing, right? So minus k minus 0 is what? Minus k only. This is A2 minus A1. How do you find the B1 cross B2? Please check. Find this right here. I cap, j cap and k cap. What is B1, sir? Over here. 2 minus 1 and 1. 2 minus 1 and 1. 2 minus 1 and 1. What about B2, sir? 3 minus 5. 3 minus 5 and 2. 3 minus 5 and 2, bacha. Okay. Can you solve it from here? Okay. Okay, I'll give you this step also. This step I'll also give you. So my B1 cross B2 will nothing but I cap times of, please check, minus 2 plus 5. Minus 2 plus 5. How come, sir? Please check. 2 into minus 1 is minus 2 and minus 5 into 1 is minus 5. Subtract them, becomes plus 5. Minus 2 plus 5. What I have then? Minus j cap, bacha. Minus j cap, sir. This is cancelled. 2 into 2 is 4. Minus 3 into 1 is 3. So 4 minus 3. Please check. 4 minus 3. When you cancel for j, second column and first row, I get 2 into 2 is 4. 3 into 1 is 3. Last one is plus k. What I get for plus k? Minus 10 plus 3. Minus 10 plus 3. Please check. 5 into 2 is minus 10. 3 into 1 is minus 3. So it becomes plus 3 after subtraction. So I'm getting B1 cross B2 is nothing but, have a look, is nothing but 3i cap. 5 minus 2 is 3i cap. Minus 1, I get plus 1, no? So minus j cap and I get minus 7 k cap. I've given you everything now. Please solve and let me know the answer. B1 cross B2 is here. A2 minus A1 is here. Mod you can also find from here, no? Very simple. 9 plus 1 will be 10 plus 49, right? So I can write here 59, no? 49 plus 1 will be 50, 59, right? Please check. Give me the answer for this part, bacha. Please check. Done. Moving on now. Okay. Derive the equation of the line in space passing through the point and parallel to the vector in the vector form. Okay, in the vector form. We can do both for Cartesian form also. We have done that. Okay, we have done this question. I have done this question in your 50 most important PYQs. Both Cartesian and vector form I have done there. Even in the model paper I have done this. Okay, so I'll do it over here anyway. Final battle, sir. We have to do it again anyway. No problem. We have x and y over here. X and y over here. This is the point origin. Let's say the point passing through this. The line is passing through this point A with the coordinate of x1, y1 and z1, bacha. This is a line, let's say, call it to be B. AB is the, this is x, y and z, okay. Position vector of this point A is nothing but A. Let's call this to be vector R. This is the vector AB and this is parallel to the vector B, sir. Parallel to the vector B, sir. Okay. And vector B is given like this, please check. A I cap B j cap plus C k cap, sir. This is the vector B defined as with the help of direction ratios A I cap, B j cap and C k cap. Okay. So how do you find it, sir? We can know from the triangle of addition. From triangle law of addition, what I get? Please check. I'm getting here OB equals to OA plus AB. Vector OB equals to OA plus vector AB. Please check. OA plus vector AB. OB is the resultant vector. OB is the resultant vector for OA and AB. Okay. So, sir, OB is R. Right here. Vector R equals to OA, sir, is vector A plus vector AB. What is vector AB, bacha? Please check. Vector AB is nothing but parallel to vector B. So right here, vector b, lambda times b. Property of collinear vectors. Property of collinear vectors. This is parallel to this, no? So vector AB will be lambda times of b, right? Lambda times of b, because they will be proportional, no? So let's say the constant is nothing but lambda. Correct, na? AB will be proportional to b, right? They are collinear vectors, parallel vectors. Okay, that's why let's call the proportionality to be lambda. So I'm writing AB as lambda b. Okay, put it back over here. I get R equals to A plus lambda b. This is vector R. Okay. Now put the values of R. What is the value of R, bacha? X I cap, Y j cap, and Z k cap. What is that? X I cap plus Y j cap plus Z k cap equals to, what is A, bacha? X1 I cap plus Y1 j cap plus Z1 k cap. Okay, what about this, sir? Plus lambda times of A I cap plus B j cap plus C k cap. Answer is done, sir. Vector form is clear. This is a vector form actually. We can write in this form also, not a problem. One step we can write, no more step. Done. This question is done, sir. Let's move on now. Chaliye, let's move on now. Linear programming now, sir. Let's solve questions on linear programming with learning everything what we have to do in the chapter. Okay. Very simple concepts is there, not much difficulty in this particular chapter. What is there? This is very, very important. Objective function. Your objective function, bacha, it'll always be linear in nature. You know that very well. Okay. With the help of that, you need to have, sir, constraints, bacha. You need to have constraints over here given to you. Okay. With the help of constraints and this non-negative constraint, bacha, basically in the first quadrant, we'll plot the graph. Okay. And from there, we'll look for feasible reason. Then with the help of the corner points, we find our optimal solution. We find our optimal solution of the objective function using either maximization or minimization. They can ask you to do anything, no? Optimize for maximization or optimize for minimization. Chaliye, let's solve the questions now. Not much is there in this, okay? Chaliye. Feasible reason is what? A feasible reason is the common area satisfying all the constraints. It can be bounded or unbounded. Optimal solution lies at a corner point vertex of the feasible reason, okay? Graphical method we can use, bacha, right now. Don't worry about these steps. I'm going to teach you everything in detail, okay? Okay. What we have, question number 1. The optimal value of the objective function is attained at corner points of feasible region. Option C is correct. Correct, no? The number of feasible solution of LPP can be infinite, no? It's an area. Okay, can be infinite, sir. Optimal can be unique, okay? Optimal can also be more than one, but can be unique also. But in the case of feasible solution, we can have more than, of course, one all the time. Okay? Because it's the area, sir. Excuse me, it's the area, bacha. That's why. Then, okay, I wrote option C, no, it's incorrect, bacha. I read it as infinite actually. Option D is correct. I was thinking infinite only in my mind. I thought it is given as infinite. So option D is right. Option D is correct. Infinite. Okay. Infinite answer is there. Maximize Z. 3x plus 2y subject to the constraints. X plus 2y less than 10. 3x plus y less than 15 in the first quadrant. X greater than 0, y greater than 0 means first quadrant only. Let's do it. Draw the graphs. This is x. This is y. First, bacha will write the objective function. They given z equals to 3x plus 2y. Next step is write the first constant without the inequality. So right here, x plus 2y, okay, equal to 10. Put here x as 0, we get y as 5. Put here y as 0, we get x as 10. Plot on the number line. X is 0. X is 0. Okay. I get, okay, x is 0, y is 5, no, somewhere over here. And x is 10, y is 0 over here. This is your number line. Please check. What is there? The points coordinate I can write 0, 5. And this point is nothing but 10, 0. So 10, 0. The line is what, sir? The line is x plus 2y, no? Less than, if I'm looking for less than 10 means below, bacha, means below this thing. Please check. My answer, my area will be, the feasible region will be below this line. Okay, they have given inequality as less than, no? Next one we will take, what we have next one as 3x plus y less than equal to 15. I'll write without the inequality. Write without the inequality. So write equal to 15 to get the again the corner points. Put here x as 0, y is 15, y is 15, and when you put y as 0, x is 5. Y is 0, x is 5. So put here 0, 15 is somewhere over here. 0, 15. First point. Okay. Other one is what, bacha? Y 0, x is 5. So somewhere like this. This is 0, 5. Sorry, 5, 0. No. Excuse me. 5, 0. So this point will be 5, 0. So what's the equation of this line? 3x plus y is less than 15. Less than means, bacha, again below this. What is my feasible region then? In that case, very simple. This is my feasible region, bacha. I already have the corner points. I need only one. This is 0, 0, 5, 0, 0, 5, and this point I need. Okay. Solve this equation to get this right. What I have, first one is x plus 2y equals to 10. Another one is 3x plus y equal to 15. Equals to 15. Let's do one thing. Multiply this with 2. Multiply this with 2. What I get? 6x plus 2y equals to 15 times 2, no? So 30, right? Correct, right? 30. And then write this equation again. I get here x plus 2y equal to 10. Subtract it now. This is cancelled. I get 5x over here. I get 20 over here, which gives me x is nothing but 4. X is 4. What is going to be y, bacha? Y has to be 3 actually. Please check. X is 4, no? 4 plus 3 times of 2 will be 6. 4 plus 6 is 10. So 4, 3. Y has to be 3. Please check. Please check, sir. Check here also. 4 3 is 12, no? 12 plus 3 is 15. So y has to be 3. So points are, what are the corner point, bacha? 5, 0, 0, 5, 0, 4, 3 and 0, 5. Okay. This is your feasible region. This is your feasible okay, feasible region, excuse me, feasible region, sir, feasible, okay, feasible region. Okay, chaliye, let's move on now. Okay, let's move on now. So what we have, corner points here. So right here corner points, and right here objective function. What is that? 2x plus I think 3y, no? Or 3x plus 2y. Let's check. 3x plus 2y actually, ulta. Right here 3x plus 2y. 3x plus 2y, sir. 3x plus 2y, sir. Now what are the points we have? 0, 0, 0, 5, 5, 0 and 4, 3. 4, 3, right? We're looking to maximize, no? So right here there will be 0 actually. 0 into 3 is 0, 0 into 2 is also 0. What about this? 0 into 3 is 0, sir. 5 into 2 is 10, giving me 10, sir. What about this? 5 into 3 is 15 plus 0, giving me 15, sir. 5 into 3 is 15, no? 15 plus 0 will be 15 only. What about this? 4 3s are 12. 4 3s are 12, sir. And 3 2s are 6, bacha. Please check. 4 3s are 12 and 3 2s are 6, giving me 18. This is your maxima. So what I am getting? Z max is nothing but 18 and occurs at what is it? 4, 3, no? I'll write here 4, 3, bacha. This is the final answer. Please check. Okay. This question will carry 6 marks. Will carry 6 marks. So either, so only change that they can give no in this question. Instead of giving you this no, they can give you a word statement. They can give you a statement in the word. A problem will be given you to from the word. You can have to find the assign the variable first, and then what, make your objective function and the constraints. But not be difficult at all. It will not be difficult at all. Please check. Done. Okay. Chaliye. Now the chapter is probability. Okay. What we have in this basic formula probability, we need conditional probability, sir. We need also Bayes theorem. Only these things is important for us for our board's point of view. Okay. So please check over here. This you know, right? Basic formula. P is nothing but favorable outcome by total outcomes. We know this. For total sample space, bacha, probability is always 1. Okay. For nothing, for null set, what is the probability? 0. Okay. For impossible event, probability is 0. Any probability can be more than 0 and less than 1. It cannot be more than 1 at all. It can be equal to 0 also, it can be equal to 1 also, but never be less than 0 and never be more than 1. Okay. Probability of a complement of a set bacha will be same as 1 minus probability of the set. Probability of the complement of a set will be same as probability of the 1 minus probability of the set. Okay. Set E is there. Probability of complement of E will be nothing but probability of 1 minus probability of E. Okay. Same bacha, we have A and B will be given by probability PA plus PB minus P of A intersection B. We also have P intersection B will be 0 when you have this condition is true. Okay. Not use that much, but we'll see. What about this? So PA intersection B will be PA into PB for independent events. For very useful to us. Very useful to us. What is this bacha? This is not there much, but can be asked. Means there is nothing common between the two events. That's why it is 0. Hence the result is like this. Nothing is common now. So 0. This is independent events. Very important. Very important. Okay, please check. This is done. What else we have? Sir, conditional probability means looking for the probability of the event A when that P has already occurred. Probability of the event B. Also B has already occurred. Looking for the chance of event A to occur when B has already occurred. B has already occurred. Please check. It will become PA intersection B upon PB. PB cannot be equal to 0, of course. Already occurred, no? Some chances will be there, no? For this to be occurring. Again, from here we can write bacha, cross multiply PB into PAB. Let's cross multiply this. PB into PA, conditional probability with B. The base theorem. Okay. Again, event A has already occurred. Looking for PB. Actually, what will happen? PABI times of PBI plus upon the sum of all this. Basically, what is this called as? This is called as total probability. Total probability. Sum of all the events. Okay. Please check. Chaliye. So B1, B2, B3 are the mutually exclusive and exhaustive events. Okay. Great, sir. First one question on this. P is given as 0.6. PF is given as 0.3. They've given P E intersection with F is nothing but 0.2. They're asking us, sir, PE conditional with F, that F has already occurred. It will be PE intersection F upon PF. How much is that? 0.2 upon PF is how much, sir? 0.3. What I get? 2 by 3. What I get? 2 by 3. Answer is option number B. Option number B. Please have a look. This is done. Great. Okay, moving on. If A and B are any two events such that PA plus PB minus PA intersection B and means bacha intersection PA plus PB minus PA intersection B is equal to, sir, P of A. PA is cancelled. I'm getting here PB equals to PA intersection B. PA intersection B. Okay. Now, great, sir. Great. Chaliye, what are they asking? PBA, no? They're asking us PBA, sir. PBA. It'll be bacha. Please check. It'll become, sir, PB intersection A upon PA, na? PB intersection A upon PA, right? What is this given as bacha? This is from here. Please check. PB upon PA. Correct, no? Probability of the event B intersection A is nothing but same, no? Intersection of B, AB. B intersection A is same as A intersection B. Okay. So get this as PB. PB by PA is the answer. Option C is correct. Option C is correct, sir. Easy. Easy only, right? Chaliye. Now, sir, we have relation and functions. Okay. Types of relation, bacha, will be, we know this reflexive relation. What is that? If the number related to itself, if the element in the set A or the relation R, okay, on the set A should be related with itself, A to A. We can have more than that. Okay, means I can have, let's say I write this set 1, 2, 3. Okay, it'll become, so 1, 1, 2, 2, 3, 3. This has to be there. This has to be there. We can also have, sir, 2, 3 also. We can also have 2, 3 also. Means 1, 1, 2, 2 and 3, 3 has to be there. I can have more than that. That is okay. But at least AA should be there. I should have ARA for sure. If anyone is missing, if let's say I have 1, 1, comma 2 2. This is my relation. Not reflexive, sir. Not reflexive. Not possible. You should have all the thing. Whatever is the set given, no, all the elements of it. Please check here. They have given here for every A from the set A. For every element of the set A, you should have A belonging to the relation R. For every element in the set A should be having A from the relation R. Done. Let me erase this now. Chaliye. What else we have? For symmetric bacha, we should have, if ARB is there, then BRA also should have been there. That's all we need. We don't need all of the elements. We need for every ARB, for every AB, we should also have BA. That's all is the requirement. Not for all the elements. For every AB, whatever is the combination you've taken, only one you have taken, it's okay. You've taken only 1 2 2 1, it's okay. It's symmetric. You don't have to take 1 1 2 2 1 1 3 3 1 like that. Not for all the elements. If 1 2 is there, then 2 1 has to be there. If 1 3 is there, means 3 1 has to be there. Not that 1 2 should be there and 1 3 should also be there. Any of the case, okay? 1 2 should be there, then 2 1 is there. If 1 3 is there, then 3 1 is there. If 1 2 is there, let's say, and 2 1 is there, and there's no 1 3. Let's say there's 1 2 and there is 2 1. There's no 1 3. It's okay. It's still symmetric. Still symmetric, sir. Still symmetric, sir. Let me erase this as well. What I get now? For transitive relation, what I get? There should be ARB and there should be, please check, BRC. This is the if condition, of course, and there should be ARC, sir. There should be ARC, sir. Please check. ARB should be there. If ARB and BRC is there, then ARC has to be there. Okay. And if a given relation R is symmetric, reflexive, and transitive. If any given relation R is symmetric, reflexive, and transitive, then we can call the relation to be equivalence relation. Equivalence relation. Please check. Okay. Let's move on. What we have for functions? Again, we have a one function, onto function, and bijective function. One function is also called as injective function. Onto also called as surjective function, and bijective function will be a function which is both 1 1 and onto. How can they call such a function 1 1? If I have this condition true, okay. For all FA1 equal to FA2, you should have A1 equals to A2 as well. For all FA1 equals to FA2, you should also have A1 equal to A2 as well. Okay. For onto bacha, the codomain should be equal to the range. Then only can we call function. Then only we can call the function to be onto function. Is that clear? Okay. We have the graphical approach, of course. In this, we look for only one transaction. So unique mapping should be there. From where to where? From the domain to codomain, sir. Means one element in the domain should have only one image in the codomain. Okay. Please check. This is done. All right. Questions now. Short and precise. We'll do the work and move on. Question is there, sir. So that the function R to R, okay, this is a good question. Please check. Function defined like this. F, okay, R naught to R naught, given by, fx is given by 1 by x, okay, is 1 1 and onto, where R naught is the set of all non-zero real numbers. Non-zero means it can be negative also, positive also. Means R naught can be, what is R naught, sir? All real numbers except for 0. All number except for 0. How come, sir? Of course, the 1 by x is there. If you put x is equal to 0, what will happen? It will be undefined. X will be not equal to 0, no? So R naught is what, sir? All real numbers. Okay. Chaliye. So let's check, sir. If I write like this, 1 upon x1 equals to 1 upon x2. What is this, sir? This is the value for your, basically, f of x1, f of x2. I'll write it again. Please check. I'll write again. Have a look. F of x1 equals to f of x2. What I get? 1 upon x1 equals to 1 upon x2. From where I am getting x2 equals to x1. x2 equals to x1. It means, sir, function is 1 1 in nature. Function is 1 1 in nature. Okay. And of course, please check here codomain, sir. Codomain is bacha over here. Have a look. Codomain is, sir, all real except for 0. What is the range, bacha? What is the range? Have a look. Range will be, again, range will also be all real except for 0. You can see here, codomain equal to range, sir. It means onto. It means fx is onto as well. Fx is onto as well. If you want, you can check from here. I have y equals to 1 by x now, so x will become 1 by y. Okay, now check. Y is, sir, everything except for 0. Same goes with x also. Same goes with x also. So that's why it's going to be for any y from the codomain, I get the x in the domain. What is this, sir? Y, sir. Y cannot be 0. That is okay in the codomain. X will also be the same case. Okay. If you want, you can see the graph also. This is a graph, right? So this is the graph, right? Check here. Any point you take, you have only one intersection. 1 1 onto bacha. 1 1 onto, sir. Always 1 1 onto. Please check. Done, sir. What else we are asking now? They are asking us, is the result true? Yes, it is true, sir. If the domain R0 is replaced by N. Okay. Okay, what are they asking now to us? The domain now, so basically the function is now defined like this. N to, okay, N to R0. N to R0. Okay. But it will be 1 1, okay. What will happen? Please check. If I take N1, no, what will happen to the graph? Please check. It will be like this only, no? It will be like this only. Please check. If I take domain to be only natural number, domain is natural number. It means 1, 2, 3 like this. Okay. So what is the bacha your range? Just check. If I write here, so 1 1 is okay, no? It's 1 1 function only. It's a 1 1 function. All right. So it's going to be 1 1 only. What about onto? You check. What about onto? So if you check over here, have a look. So onto, sir, we have y equals to 1 by x. Okay, y equals to 1 by x. What does x becomes? 1 by y. What is y, bacha? They're saying codomain is same, sir. Codomain is same. So y is nothing but belonging from all real numbers except for 0. All real numbers except for 0, bacha. Okay, means I can take, bacha, I can take y equals to, let's say 1.2 or 1.25 I can take. What will happen to x value, bacha? X will become 1 upon 1.25. Is this a natural number? This is not a natural number, sir. It is not a natural number. It means when you take y as all real except for 0, what happens to x? It's not natural anymore. It means you're getting for some y value, x is not natural. It means what happens, sir? What will happen, sir? It's not onto. So your function fx now will not be onto function. Please check. I'll repeat myself. First part was to prove it is on 1 or onto or not. We did that by proving 1 1 and onto like this. We saw the graph part as well. This is a graph part. Okay. Second part, they are saying that domain is changed to natural number. Okay. 1 2 3 like this. It is going to be 1 1. See the graph. Same thing, bacha. It will be 1 1 only. Only natural part will come. No, you will not have on this side. You will not have this graph, bacha. You will not have this graph. How comes this numbers of x? These are not natural numbers, sir. Natural numbers start from 1 only, right? So you don't have the left hand side graph. So I can remove this, no? I don't have this part graph. So that's why I'm not taking it over here. There's no graph on the left hand side. Okay. So if you still take the intersection, you get 1 1. You get the function to be 1 1. Okay. The function fx is 1 1. Not a problem. What about onto, bacha? If you take y from the R0, what is R0? Everything but 0. So I get 1.25. Okay. It'll get x as a number which is not natural number. It means not onto. So the result for the second part, what I'm getting, I'll write it over here only. For this part, what I'm getting, for this part, second part, I'm getting not onto but 1 1. I can write here 1 1 but onto. Your choice. 1 1 but onto. Okay. Function after this change. This was second part. Okay. This was second part, bacha. After this, replaced by n. Have a look. It's a very good question. It's a very, very good question. Okay. Chali. Once again, I will show you. Okay. So that the relation R on the set A of point on coordinate plane given by, okay, PQ, distance OP equals to OQ, where O is the origin, is the equivalence relation. Okay. Please check. So if I take, bacha, for reflexive, no, excuse me, if I take for a reflexive, sir, what will happen? I have to take the same point, no? Let's say I take here ARA. Okay, I take, bacha, point A actually. What will happen if I take, let me write this as ARA. I get here point OA equals to OA, no? A line is equal to itself. A line distance will be equal to itself. A point distance, bacha, like this. This is the point A, right? So of course the point OA will be equal to itself, no? Okay, so of course sir, relation R will be reflexive. Will be reflexive, sir. Is reflexive, please check. What about symmetric, sir? What about symmetric, please check. Okay, if I say that I'm writing here, let's say PQ, okay, it means from here OP or PO equals to OQ. Okay, I'm writing over here bacha RQ, okay, ulta QRP. What it implies? OQ will be equal to OP. Same thing, no? PO equals to OQ or OQ equals to OP, same thing, right? Correct, na? It means bacha, the relation R is symmetric as well. Symmetric as well. Let's look for transitive now. Let's look for transitive now. Okay, I take 3 points PQR. Let's write here PRQ. Relation of P with R and Q. What I get for this? OP equals to OQ. Let's write here QR. Okay, I write here S, QR and S. Okay, what happens to this bacha? It will become QO or OQ equals to OS. Okay, so from here I can write bacha, please check. OP equals to OQ, OQ equals to OS. It means OP equals to OS. What it implies? It means, sir, actually PRS is also there. Please check. PRQ, PRS is there. PRQ and QRS is there. It means PRS also is there, bacha. It means the reflexive relation is also transitive in nature. Please check. We have here so far reflexive, symmetric and transitive. It means, sir, the relation R is equivalence relation. Equivalence relation. Have a look. Done. Done, sir. Let's move on now. Okay, simple enough. So that the sigma function FR2R is neither 1/1 nor onto. How do you define the function this, sir? I can write it this in terms of x will be given by mod of x upon x when x is not equal to 0. X is 0 means it's going to be 0, sir, actually. Okay, please check. So if you define, sir, this function, let's say x after 0, what happens here? So fx bacha will become 1, so simply x upon x becomes 1. If I write, sir, x less than 0, what will happen bacha? Function will become, fx will become, so please check, minus x upon x, na? The mod will open with a minus sign. Minus x upon x will become, sir, minus 1. Okay, so have a look what I'm getting now. The graph, if I draw, I'm getting the graph like this. At 0, this is going to be 0. After 0 will be, of course, over here is open and then goes to 1. Okay, and before will be again open and goes to minus 1. Okay, check here. So whether you take x as 1, x as 2 or any number, what is the value of fx bacha? Going to be 1 only, right? It means not 1 1, not 1 1. What about onto bacha? Please check. Range you check now first. The range value is nothing but minus 1, 0 and 1. Individual numbers. Minus 1, 0 and 1 is the only range. What about codomain, sir? Codomain is coming as bacha. Please check all real. But we can say range is not equal to codomain. It means what, sir? Fx is not onto function. So we get here fx is not onto and here not 1 1. Please check. Done, sir. Neither 1 1 nor onto. Neither 1 1 nor onto. Done. Simple enough. Very simple. Okay, chaliye. So just some time you have to spend with me. Little bit more patient. We're gonna complete this chapter and go ahead and complete ITF as well. Okay, that will complete your entire Maha revision, maths revision for final battle of PU2. Okay, what is that? So that the relation R on the set of real numbers R is defined by R equals to a comma b such that a less than equal to b square is neither reflexive nor symmetric nor transitive. Okay, chaliye. Reflexive bacha will take first. Okay, what is the given condition? We have a R a. It means a should be equal to less than equal to bacha a square. A should be less than equal to a square. Let's take, if I take, sir, 1 by 2. Okay, 1 by 2 if I take a as 1 by 2, check this out. Can I take 1 by 2 less than equal to 1 by 2 square? Check here. 1 by 4. Is it okay? Is it true? No sir. No sir. It means therefore relation R is not reflexive. I've taken, because so they have given here on real numbers, no? They have given here on real numbers. So for real numbers, is 1 by 2 not a real number? Is correct, okay? A equals to 1 by 2 is nothing but a real number, right? If I take that, sir, it's a real number. If I take that, bacha, what will happen? I'm getting this not equal to. This condition is not verified. Not verified, sir. It means, bacha, what will happen is not a reflexive relation. R is not reflexive relation. Let's look for symmetric now. Think about it. If I have A is less than equal to B square, then how can I have, sir, A greater than equal to, sorry, excuse me. This will be from where? A R B. Can you write this? B less than equal to A square. Will this be okay? No sir, of course not. Think about it. If I take 2 less than equal to, if I take 2 less than equals to, sir, 2 square, okay, or I take, let's say, 1 second, okay, I write here B R A, not possible, sir. I'll show you example. If I take A equals to 1 I take and B equals to 4 I take, please check A R B, sir. It gives me 1 is less than 4 square, okay. Now if I take B R A, bacha, what will happen to this? Please check. 4 is less than 1 square. Not possible, no? So not possible, sir. It means the given relation R is not symmetric. Not symmetric. Am I right? Okay. Let's look for transitive now. Let's look for transitive now. What I get? I can take here the relation, let's say 2 minus 2 and minus 1. 2 minus 2 and minus 1. Okay. Chaliye, what will have, bacha? Please check. I can write this as, for this to be transitive, I should have this condition, no? A should be less than equal to B square, B should be less than equal to C square, and A should be less than equal to C square, right? Okay. So this is condition coming from, please check, A R B, B R C, and over here what I have? A R C. Okay. Please check what I'm getting. So from here I'm getting, sir, 2 is less than minus 2 square. Correct, sir. This is right. Okay. This is correct. What about this now? I'm getting over here is minus 2 is less than equal to minus 1 square. This also is right, sir. This also is right, sir. What about this? I get here from this 2, I get 2 is less than equal to minus 1 square. That is incorrect. Okay, it means ARC is not validated. Okay, ARB is there, BRC is, but ARC is not there. It means, sir, R is not transitive. R is not transitive. Okay, chaliye. So same thing. I hope you got it. Please check. Okay, please check. All right, sir. What I have, this is for symmetric, right? 1 second. I'll write it over here. I'll write this over here, sir. Okay, this is S for symmetric. Let's move on now to next question. This is clear, right? Reflexive, symmetric, and transitive part is over here for transitive. Okay, so not symmetric, not reflexive, and not transitive. Question is done. Let's move on now. This is clear. Let's move on to next question. What we have now, sir, is in the last chapter that we have to deal with ITF. The last thing. I just said this chapter has only, so in the previous chapter, bacha, I have given you highlights of the chapters, okay? So in relation function, you have to do, of course, definition of the three relations, reflexive, symmetric, and transitive. Then you have to do in 1-1 onto function, okay? Again, look for questions for bijections and the questions of 5 marker, okay? Where you have to find out 1-1 onto or not, prove that, like that, okay? In this case, you have to remember this table, okay? This table, very, 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 very important, extremely important. Domain and range, because they ask you simply domain or range, principal branch, they ask you like this for any inverse trigonometric function in one MCQ. They can ask you that. That's why you have to remember this. Okay, you have to remember this table. For sine inverse, we have domain is minus 1 to 1, range is minus pi by 2 to pi by 2. Okay, again, this is called as principal value branch. We know this, right? Otherwise, we can't take the inverse. No, we had to truncate the domain, no, of sine function. Same goes with cos inverse, 0 to pi over here in the principal value branch, and minus 1 to 1 is for the domain. Tan inverse are all real, minus pi by 2 to pi by 2, open. We have cot inverses all real, 0 to pi, open. Please check. Okay, for sec inverse bacha we have to take out pi by 2, and for cosec inverse bacha we have to take out 0. Okay, chali. Now basic identity is there. This is again a lot of questions are being solved on this. They ask you in this PYQs, sorry, in the MCQ as well. You can see the PYQs. Question has been asked on this property. Question has been asked in this property. Okay, sec inverse of minus x is nothing but pi minus sec inverse of x. Remember this? Okay. This also not has been asked much many occasions, but still good to know this. Not a problem, no. Simple formula: sin inverse of a cos inverse of a is pi by 2. Why, sir? Because sin and cos is complementary ratios. Same goes over here. Tan inverse of a and cot inverse of a is pi by 2. Again, complementary ratio pair. Here also complementary ratio pair. This is because of complementary trigonometric ratios. Okay, chali. Again, this is also very important. We use this in a lot of questions. They ask us to prove this thing. It's a PYQ. Okay. This also has been used at multiple occasions. Please check. All right. So this also we use between sine and tan inverse. Okay. Please check. I think we have taken one question like this. We'll see right now, and that's all. Okay. So very important formulas are there. You have to remember. This we have used in the question so many times that I've highlighted it. No other reason. Okay. Now question number 1 that we have. Let's solve the questions on this chapter and complete our revision, the final battle for your PU2 boards. Any other thing you have to ask me, questions, doubts, whatever it is, you let me know in the comment section. Again, don't worry, I will be coming live before examination. Okay, on the day of your Kannada exam, I'll come live to take up your doubts. You know the how to put doubts, right? The form has been given to you. Put your doubts there. With your name, I'll call out to you. You have to be present there, and then I'll explain your questions in the live session. Okay, chali. First question that we have: find the value of cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2. Okay, let's do this. First one, sir. This is to be part A, and this will be part B. Part A, sir. It'll become bacha cos inverse of 1 by 2 will become, sir, pi by 3 plus I'll get here 2 times of pi by 6. Correct now? Sin inverse of 1 by 2 is pi by 6. You have to remember the special angles which are. Will become, sir, 2 pi by 3. Part A is done. Part B now. Find the values of tan inverse of root 3 minus sec inverse of minus 2. We get here pi by 3 for this part. Okay. And for this I get here, please check, pi minus sec, I'll rewrite it. Pi minus, for sec inverse of minus 2 bacha. Formula is there, sec inverse of minus x. Formula is there. Pi minus sec inverse of 2. Please check. I'm getting here pi by 3 minus pi I have. What is it going to be? Minus pi by 3 again. Okay. Which will give me pi by 3 minus. Please check. It'll become, sir, have a look. 2 pi by 3, no? 2 pi by 3, right? Okay. So what I'm getting over here, please check. I'm getting here minus pi by 3. Minus pi by 3. Have a look. Pi minus pi by 3 is how much, sir? 2 pi by 3. There's a minus sign, no? That's why minus pi by 3. This is your answer. This is your answer, sir, for B part. Done? Let's move on now. This question was very easy. Yes, that's how the question has been asked in your PYQs. If you check out your MCQ section. Okay. Let's move on now. Evaluate cos inverse of sin pi by 9. How do you solve it, sir? Of course, we have to use the formula for, as I said, the complementary ratios. Please check. They are very useful, bacha. Sin pi by 9 I have. No, which angle is this? Which quadrant is this? 20 degree first quadrant. Pi is 180. No, this is 20 degree. Okay. So let's write this. It'll become, sir, cos, one second. Cos inverse. I'll write this as cos inverse cos of pi by 2 minus, please check, 7 pi by 18, sir. 7 pi by 18. How come, bacha? How come, sir? Okay, one second. Is it right? Is it right? Pi by 2 minus cos, pi by 2 minus this becomes a sine. No, not right. Not right, sir. Pi by 9, no? Pi by 9. I'll write the answer. I wrote the answer first. It's going to be pi by 9 actually. Please check. Pi by 9 actually. What will happen to this? Cos of 90 minus theta is sine theta, sir. It is sine theta, sir. Cos of 90 minus theta is sine theta, sir. What I get now? Please check. I'll get here cos inverse of cos. LCM is 18. 9 pi minus. We get here 2 pi. This is the answer actually. Getting this as cos inverse of cos of 7 pi by 18. What I wrote was the actually answer. Okay. Cos inverse of cos is going to be 7 pi by 18 only. Why is this, sir? First quadrant, no? What is the angle going to be? This angle is what, bacha? This angle is 70 degree, no? Please check. This angle is 70 degrees, sir. Okay, 7 pi by 18. Write this as the answer. Right? This as the answer, bacha. 7 pi by 18 is your final answer. 70 degree, first quadrant. That's why I can take this out directly. Okay. Move on now. Prove that sine of tan inverse of x equals to x upon 1 plus x square. We just saw this over here, no? Please check. Here. Okay. No, we have not seen this. Let's solve this right now. We get, let's do one thing. Take tan inverse of x as theta. Can I do that? Of course. From here I get x equals to tan theta. Okay. Right angle triangle. This is, let's say, theta. This is going to be bacha x. This is going to be 1. This will become what, sir? Root of 1 square plus x square. Correct? Right here, from here you write sine theta. It will become x upon root of 1 plus x square. 1 plus x square. Okay. Please check what are they asking. Check the LHS now. Sine of tan inverse of x. From here you take, what is tan inverse, bacha? I have taken here as simply theta. What is sin theta going to be? This value. Sin theta will become, bacha, equal to x upon root of 1 plus x square. 1 plus x square, which is nothing but your given condition. So equal to RHS. Equal to RHS. Proved, so. A smart question, but very simple. One statement. Just find sin theta from here. We can use the Pythagoras theorem, no? Opposite by adjacent. Tan theta, sir. Tan theta is opposite by adjacent. No, this is x by 1. Opposite by adjacent. Find the hypotenuse. Find the sin theta from there. Use it over here to get the result like this. Now what we have proved that sin inverse of 3 by 5 minus sin inverse of 8 by 17 equals to cos inverse of 84 by 85. Okay, let's take this angle to be A. This will be B. Why, sir, angle? Result of any inverse trigonometric function is what? Result of any inverse trigonometric function is what, bacha? Angle only, no? So we are getting what? Sin inverse of 3 by 5 is nothing but A. It means, bacha, sin of A is nothing but 3 by 5. What is cos from here? Please check. Cos A will become 4 by 5. How come, sir? Right angle triangle you take. 3, 5 is sin, right? It will be 4 only. Na? If this is the, let's say, angle A, I get here, this is 3 by 5, no? For sin. For cos will become 4 by 5. How come, sir? 3, 4, 5 is the Pythagorean triplet. 3 square is 9, 4 square is 16, 5 square is the sum of them, 25. Okay? Chali. I get sin A and cos A done. Let's move on for B now. So I get here sin inverse of 8 by 17 equals to B, right? So I'm getting here from there 8 by 17 equals to sin B, right? Let's find cos B from here. So my cos will turn out to be, please check, it will become, sir, please check, I have 289 minus 64, no? So 15 by 17. How come, sir? Please check. I have sin, right? The same right angle triangle I will make it. This angle time will be B, angle B will be there. Sin means this is 8 and this is 17. 17 square, bacha, is going to be 289. 17 square is 289, 8 square is 64. Subtract them. 289 minus 64 in the root. What I get? 255, no? 9 minus 5 is 9 minus 4 is 5. 8 minus 2 is, okay, 8 minus 6 is 2. So I get here 225. What is the root of this value? 15 only, right? 225 is 15 only, not 252, not 255. Forgive me, I said 255. It has to be 225 actually. So 15 by 17 is the value of cos B. What they've given over here, please check. I have this. Okay, I need A minus B, no? So I'll use this formula. Please check. Cos of A minus B. It'll become, bacha, cos A into cos B plus sin A into sin B. Okay? Write the values that you have. Cos A is nothing but 4 by 5. Cos B is what, bacha? Cos B is 15 by 17. Sin A is what, sir? 3 by 5. And sin B is, sir, 8 by 17. Multiply this. 15 4s are 60. 60 by 17 5s are 85. 8 is 24 and 85. Okay, what I'm getting now this side, please check. 84 by 85, right? Okay. What is this, sir? Cos of a minus b, right? Take cos inverse on that side, it becomes, sir, from here if you take a minus b will become, bacha, cos inverse of 84 by 85. Please check. Proven, sir. A minus b is nothing but this. So proved, sir. Done. Question is done. Okay. I hope this was okay. Chaliye. So I had fun, sir. It was a good session. We enjoyed all the questions. If I have missed out something, don't worry. If you want me to do any particular more question, sir, from matrix, from relation and function, whatever it is you want me to do, let me know in the comment section. I'll take those questions in the live session. I've told you on the day of Kannada examination, in the evening I will come and stay until unless you are there with the session. Once you say, sir, we are done, we are prepared, then only I'll leave. Okay, so don't worry, I'll be here to help you out in any way possible. Just leave your questions, leave your comments in the comment of this video. Okay, it's very important, bacha, because last day, no, we can't leave out anything. We have to be our best. I am working so hard. We are working so hard to deliver that. Okay, our team has been working so hard. Every day we are coming with the sessions for all of you. Okay, and just we want all our bachas to be positive, working hard. So let us know anything that you feel. I see the comments right now, sir, I'm scared. It's good to be scared. It's very good to be scared. Scared means, bacha, actually, if you have worked hard, no, if you have worked something, and scared right now means you actually want things to go good for you. It's very positive. No, take it positive, sir. Scared means good. I want it to be good. I want my exams to go good. Then, bus, after this, leave the thought. Scared, accept it. Okay, leave the thought. Now, what is important? Get to the work. You revise the formulas, learn the concept that you are missing. Okay, prioritize your questions. Go for the high weightage chapters. Just prioritize. You have the plan now, right? I've given you all the details that you need to, score good marks in your examination. Okay, so you have the plans. Stop, second guessing yourself. Start working right now. Okay, you've already done the work. Just revise everything and close it. And trust yourself that you're gonna, when the exam comes, you'll deliver. Okay, if any player start practicing in the game, does it happen? No. Remember that you have done the practice. Now it's time to deliver. I know you will. Any doubts, any queries you have, you let me know in the comment section. Questions you want, anything you want, put that in the comment section of this video. I'll take that in the live session and we'll complete everything. I'll try my best to deliver everything that you want from my side. Okay. So with this, I'm going to end the session today. See you again very soon. Till then, take care of yourself. Keep working hard, keep smiling. I know it's a tough time, but I know you will go through this and have a very, good examination after this. Take care. Bye-bye.